We welcome you to Dayton, Ohio on a beautiful day here as we get ready to make history in the world of aviation. We do have liftoff, so here we go.
I can't emphasize enough how friendly everyone is here at this competition.
Initially, we had really crazy ideas, but then we realized, that it's not so easy to do.
We're, believe it or not, flying better than ever.
Oh, he's going to put it right in the center. Now you're just showing off. Oh!
You got to stop giggling.
What just happened out there?
We're testing the limits, so we found it.
Inflatable structures can become a drone that you can carry in a backpack that can carry you.
Seems like we had a little bit of an electrical issue on takeoff.
We'll rebuild that, and then we will try it again.
Have a drone, put it up there at 3.84 on the ratio.
Teamwork makes the dream work, and we're doing well here.
It's been an awesome couple of days, and we can't wait to keep on flying here.
And we welcome you to the National Museum of the United States Air Force at the DARPA Lift Challenge in beautiful Dayton, Ohio. Slight delay this morning as rain came through this area, but it is now dried up, and we are set to go as we welcome you to day number 5. Everyone getting ready, going through the final preparations as they get down to the flight line, going through their last checks, and then it'll be all on, and you have joined us at the perfect time because we are getting close to the first flight window, and we have got some serious players. I'm Todd Harris alongside our drone expert and YouTube educator, Joshua Bardwell. JB, good to see you. Woke up this morning, saw a little bit of rain. Things were pushed back an hour. Look at this. Yeah. Sun's coming out. We are ready to go.
Yeah, it's clearing out, and we're hoping to get some flights in today.
All right. We talked to a lot of the teams yesterday at the close of the day. The excitement is definitely there. But as you look at the leaderboard, what do you expect today to happen there? And give me a prediction. Do we go 4-1?
Oh, I mean, I'm not going to bet against that, especially seeing how close we have gotten with that 3.8 4-1 position at the top. I think it would be a real shame if we didn't. And these guys are trying so hard and working so hard. It seems like we've got to do that. 2
of the top 4 teams will be in this flight window. Extreme Aerial Concepts at 3.04 in the ratio. Also chasing them, H squared there at 2.32, so they are in the money. Now, this is the chase group. Yes, they are in, but they have not reached a full competition, so that's why people say, oh, he's at 9.63, Defentex out of Moab, Utah. They haven't done a competition run yet, so they haven't hit that ratio, that threshold, I should say.
That's right, and I was thinking about that last night and thinking, going for such a high ratio, remember the minimum weight is 110 pounds. They came with an 11 or 12-pound craft, which means they don't have the option to try for anything less than about that 9-to-1 ratio. I think of that kind of like swinging for the fences. You're either going to hit a home run and clear the bases, or you're going to strike out. So far, they've struck out, but they could have the potential to really come from behind.
All right, we've got you covered from our host set here in the infield with Flight Fest just beyond. And then behind us, you've got the prep areas, and that's where the third member of our broadcast team is hanging out, getting the scoop. She is the founder of Women Who Drone. Say hello to Elena Buenrostro. Elena, you're out on the flight line this morning. How's things going out there?
Hey, Todd. So I'm in one of the prep tents right now. Most of the teams are already out on the flight line right behind me. The energy is high. We have H Square, who's on the leaderboard, as you mentioned, who's prepping right out there beside me right now. I'm excited to see what happens, but overall, most of the teams are focused. Back to you, Todd.
All right, thanks so much, Elena. Much more from you as the day continues. So we've got a flight window of 90 minutes. That's 10 o'clock to 11:30 Eastern Time. Let's not be too greedy, JB, but everyone is going to be talking about the money. And here's how it breaks down. If you're in the big money, and that is $2.5 million, but that also means you're at the 4-to-1 ratio and you complete 5 nautical miles.
That's right. Everybody has to hit that 4-to-1 ratio if they want to unlock the full prize pool, 2-to-1 ratio to unlock the half prize pool, $2.5 million for first place, $1.5 million for second place, and $1.0 million for third place, as well as those subjective categories.
We've got teams coming to you near and far. We've got a team from South Africa. We've got a team from Puerto Rico. We've got teams across the U.S., big companies, small companies, academia, mom and pop situations, and they're all trying to basically crack the code.
That's right, trying to figure out how to, well, not just break that ratio. I mean, the idea, I think, is that you set a goal. We're going to go to the West.
Right.
And then when we try to accomplish that goal, even if we make it, if we don't make it, we still learn things along the way. We still advance. We innovate. And I think that's what everybody here is focused on doing.
We're trying to educate everyone as we move along, and myself included. So if you're wondering, what is DARPA and what is the Lift Challenge? It's Defense Advanced Research Projects Agency, and here are some of the rules. Again, I mentioned you have to go 4 nautical miles with your payload, then you drop it and you do an extra nautical mile. We talked about that yesterday, practical applications.
Right. It doesn't make much sense to carry a payload if you're not going to drop it off somewhere and then come home again. So the idea is a lot of these crafts will fly very differently with loaded versus unloaded, and they have to be able to make that transition.
And let's not forget, it is a 30-minute time limit. That has not come into play as of yet. The ones who have completed competition runs have done it, around 20, 22 minutes?
Yeah, 20, 22 minutes. So nobody really seems too stressed by that 30-minute time.
All right, you know I love my weather, so I'm going to get a weather pop in here. I'm the resident Al Roker here for all those watching at home. But it is very nice today. The breeze does not seem as high as it was yesterday. Again, we had the rain come through this morning. That front has gone through. But the wind seems a little calmer, a little more humid. Is that going to affect the rotors and such?
You know, humidity does affect, they call it altitude density. So it does technically affect it, but I think the difference between a humid day and a dry day, as long as you haven't gone from the beach all the way up into the mountains, I don't think it's going to really make much difference. But the wind definitely does make a difference. We've seen some aircraft get blown over, and these guys are pushing so close to the performance limits of their craft to try to hit that ratio that normally you'd be able to resist the wind. This time it comes, you get a gust, and you just go into the ground.
Joshua, you are a stellar pilot. I'll brag on you. With these conditions, would you be excited to be flying?
These conditions right now? Yeah, this isn't too bad. We got a little bit of a breeze, but the craft are pretty powerful. And
all right, let's get to the flight line. Here we go, and we've got some great teams out there, and we will give you the lane and give you a little information about who they are. This is a great named team. This is Cactus Labs, coming to us by way of Midland, Texas. Defense Tech Group of Rolfs R&D LLC is led by Aaron Lefevers and based in Midland, Texas. This team is developing Project Saguaro, a heavy-lift VTOL UAS powered by a micro-turbine-driven warm-cycle tip-jet rotor that trades drivetrain mass for payload. Now, we saw them yesterday, and you explained some of this to me about how they're escaping the exhaust out through the tips of that rotor.
That's right. You can't quite see it from this angle, but there is a turbine engine. It's a little red turbine engine down at the bottom below the fuel tanks. Turbine engine is blowing exhaust gases, and a lot of times you would just direct that backwards. It would push a plane forward. Instead, they are ducting that up through kind of a stovepipe and out the tips of the rotors. So the rotors are carrying that 700-degree exhaust gas.
So you saw them just spinning up, just getting the feel for it. There you see H squared. They are on the leaderboard, currently sitting in 4th place. This team with an interesting design out of Boston, Massachusetts. They're in the small business category, and their team is made up of engineers, drone enthusiasts, RC pilots, and innovators skilled in advanced mobility, robotics, and systems integration. Their words, not mine. They say they're passionate about pushing boundaries, and they have come to the right place. Now, let's take a look at the highlights, JB, from their run from the other day, because they are already on the big board with a great run, so they are in good shape. So they don't have to do any more test runs. They are ready to rock and roll.
That's right. As long as they have passed their safety check and their test run, they can continue to run. If anybody were to make a change to the aircraft, like if they were to crash and have to repair it, they'd have to redo that test run. But here we see them doing a run. It is a more traditional helicopter-style craft with one big main rotor, and then a tail boom and a tail rotor. And that has proved pretty successful in this competition.
Turning much easier for these kind of vehicles?
Yeah, turning is easy. You have to fight to keep it from turning, that tail rotor. The weight is up underneath that great big rotor, and as we talked about, the larger the wing, the larger the rotor, generally the more efficient it is.
But how about this, Lenny? I mean, I have some pilots, won't name the airline, but they could learn a thing or two about this, Lenny. How about this? Look at this.
Yeah.
Smooth as butter.
Smooth as butter. Smooth, in control, precise, exactly where it needs to be. That's what you want to see.
All right, so we will see what they can do today. H squared out of Boston, Mass, currently sitting in 4th place overall. They are on the flight line. Looks like they are ready to go. That thing looks even shinier than it did 2 or 3 days ago.
You know,
Okay, this is Extreme Aerial. I think they are also on the leaderboard. If I'm not mistaken, they are in 2nd place.
2nd place. And we see the weights underneath there. I checked, those are 45-pound plates. So if we start counting plates, well, I'm not going to try to do math in my head, especially not on a live broadcast.
How about this ratio? 3.31.
Yeah, we can see that ratio down in the lower right. We don't have to do the math. 3.31 ratio.
So this is an increase in payload, and the ratio does go up. but this would keep them in second if they complete it. Now, let's not forget this. They've got to go 4 nautical miles with that weight. Again, 181.9 pounds. Come back, drop it off, then go back out, complete another nautical mile for this to count. So it's a gradual improvement. So, JB, my question to you would be, what's the purpose of just going up at these kind of small increases?
Well, yeah, you might think if you know it's not going to change the placement, then why wouldn't you take a bigger
Correct.
bite? And we saw an example yesterday where the craft did a successful run, they added weight, and then it tried to take off, and the rotors completely separated from the additional stress. So if we were to speculate, we could say that they might be not trying to take too big of a bite and damage their craft.
Okay.
They're going to see how it flies here. They may not even do a complete run. No, I do see in the upper right it's green.
Yes.
So that does mean this is an official scored run. But they are allowed to make multiple runs. So they could do the run, secure their place, try again with more weight later.
Another number to keep an eye on, that altitude there on the upper right. That's at 150, 160 now and holding. They've got to stay above 100, stay below 200. If you dip below 100, the run automatically comes to an end, and that bird better stay clear.
I probably wasn't as close as it looked, but it did look like it kind of was like, oh, I'm getting out of here. It did
like
not
who's
like
going to
the
get a
look
Randy
that I did
Johnson
it.
fastball there across in front of the home plate.
And we see them doing their turning back and forth. They have this full course. They can't go outside the bounds of the course, but they are not required to go all the way to the end of the course. They can turn around as many times as they want whenever they think it's advantageous to them. The total distance that they have to travel is 4 nautical miles with the weight and 1 nautical mile without.
Well, they're 3.5 nautical miles away from dropping off their payload and then continuing on. Remember, it's a 30-minute time limit. Should not be a problem as we do the quick math. They are well over half a nautical mile into this at 2:41, so that would hold that they're going to be closer to around 15 to 17 minutes on a complete run. Again, the pay ratio is at 3.31, so not quite 4.1, but definitely trending up.
And I can't help but notice that their total vehicle weight is 54.9 pounds. Of course, the maximum weight allowed is 55 pounds. Per FAA regulations, that would allow them to fly and test their aircraft at home. We have a special waiver here from the FAA to fly above the normally allowed weight for the purpose of the competition. But man, that 54.9 pounds makes me think of me going to the airport trying to check a bag.
Right.
And I got one pair of socks too many. They are right up against it.
You talk about the weight and the payload that they're carrying, as we mentioned again, about 182 pounds for a craft that only weighs 54.9 pounds. Now, within that 30 minutes, they've got to come in, land, and take that out. We've seen some crafts that can release it automatically, have a fulcrum or a switch to just release it. This does not look like the case. This looks like it's going to take some human involvement.
Yeah, that's right. And we haven't seen very many teams doing that. You might think with the clock running that you would like to automatically disconnect those weights. My thinking about that is that time hasn't really seemed to be a factor. Right. Everybody has roughly 10 minutes to spare to get those weights off.
But if you have a bad Formula One NASCAR pit stop getting those weights off, then it could be a problem.
Theoretically, they could push themselves over the time. But if you were to develop that dropper mechanism or disconnector mechanism, that is engineering resources you have to devote and time and money.
And probably adds weight.
Adds weight and potentially could break.
Yeah.
And frankly, I don't blame them for not doing it because these guys have so many other problems to solve just trying to hit that.
This is Extreme Aerial out of San Jose, California. And they do also have some company in the air right now on the flight line, just getting word that H² is up and running, the team out of Boston, Mass. We saw them just quickly on the flight line firing up. So we've got 2 aircraft up and going, but this is the one that's the furthest along. This is Extreme Aerial Concepts, 4.445 into their run. And there is H². If I'm not mistaken, they were in 4th place. So they bumped up their ratio. 2.32 had them in 4th place. This is 2.96, and if I do some quick math, if they complete this would bump them up a position, JB, into 3rd place.
Yeah, and it really matters because 1st, 2nd, and 3rd place are in the money. And so you might think, well, I'm in 3rd place, but you got a lot of people chasing you, and I would certainly feel better if I was in 2nd or even 1st, knowing that it was just that little bit harder for somebody to knock me out.
If you're in a football game and you're up by 3 in the 4th quarter,
you don't
rather
like
be
that.
up by 6.
Yeah, absolutely.
There you go.
So everybody, even if you doesn't change your position, you're always trying to increase that ratio.
Sure.
Number one, I mean, we shouldn't overly focus on the prize money. Obviously, it's a lot of money, but these people are in it as much for the prestige, as much for just the sheer challenge, as anything else.
If you're just joining us, it is just after 10:15 on the East Coast here in Dayton. This is day 5 of the DARPA Lift Challenge at the National Museum of the U.S. Air Force. Where have you been? You've missed out some great stuff, but we're glad you're with us. This is a qualifying run, a scoring run, we should say, run number 6 for the team H squared from Boston, Mass. As they continue on, remember they have to go 4 nautical miles, drop the payload, then go and do another nautical mile. We'll go back to extreme aerial.
One of the things I noticed about these two very similar craft, sort of helicopter-style rotorcraft, there is one difference. Extreme aerial has their weights mounted vertically, and H squared has their weights mounted horizontally. I'm not sure that that's going to make too much difference in terms of like the handling of the aircraft, the center of gravity. Technically, mounting them horizontally does move the weight a little closer in to the center of gravity, maybe make that aircraft a little more nimble. But for me, mostly I think this would make a difference in loading and unloading. If I'm thinking about putting those weights on with the horizontal one, I'm going to need to support those weights in some way. We saw that H squared had some kind of a stand.
Right.
And one reason for that, maybe they put the weights on the stand, they set the aircraft down on top of the weights, they bolt them on. Whereas if they're horizontal, I can just slide them onto that bar. On the other hand, the engineering problem, getting those weights to stay on that horizontal bar, that's a lot of weight and a lot of leverage.
You were talking about either vertical or horizontal. I guarantee these folks have not missed a thing. They know which one is going to make their craft more efficient.
Yeah. Well, in the process of loading and unloading.
Remember, they've got to stay above 100 feet on the altitude, below 200 right now, no problem for Extreme Aerial Concepts. The team is just moving right along out of San Jose, California. They are currently into this run, 2.16 nautical miles in, so they are more than halfway through their weighted portion of the run, and then they will disembark that weight payload of 181 pounds, and then they'll be on their way for another nautical mile. We're also keeping our eye on H squared, the team out of Boston, Mass. And they didn't waste any time on this, JB. They got right into this as the flight window opened up. Within 10 minutes, they were up and going.
And we've seen teams come out, and for whatever reason, they're not immediately ready to go. Sometimes it takes them 20, even 30 minutes before they make their first attempt. Teams are allowed to make multiple attempts within their flight window, as long as they're able to land before the time expires on the flight window.
So there's a situation where they could come back in and say, okay, we're at the payload of 3.31 ratio, 181. Let's tack on a little more weight, see if we can hit 4.
Absolutely.
Would they make that big of a jump, do you think?
Hard to say. I mean, they are limited in the, they have to add plates. So they don't have to add a full 45-pound plate. The minimum increment, I believe, is a 2.5-pound plate.
Okay.
So they're going to have to work within that constraint.
Just so you know, 3.84 is the ratio that has the lead right now. So no one has hit the magic 4-to-1 ratio, but we still have tomorrow and Sunday.
And Todd, let me talk about that ratio just for the viewers who are joining us today. That is the payload to weight ratio. So the weight of the aircraft plus its fuel or batteries relative to the weight of the weight plates that they put on. And the challenge is focusing on that so much because ultimately the cost per mile per pound to carry cargo is what is a limiting factor in how sort of ubiquitous and the number of things we can try to do with these aircraft.
Financially speaking, that's a sweet spot.
Yeah. Well, the more you can push that number down, the analogy I like to use is, when all we had was really slow internet, nobody would think of a streaming service. And now that we have fast, cheap internet, suddenly we just put everything on the internet. We can stream it no matter what we want. Right now, UAS cargo aircraft are kind of like that slow internet of the 80s and the 90s. We can't do a lot with them because it's too expensive. And if we can push that payload to weight ratio up, we can open up all these possibilities for new things we can do with them.
All right, we are in the midst of the first flight window of the day, pushed back an hour because of the weather in the Dayton area. This is 11. We'll spin you back to lane number 3. This is H squared out of Boston, Mass. They're a little bit further behind as they are coming up on 2 nautical miles, so they're approaching that halfway point before they'll drop their payload and then complete another nautical mile.
Another thing I noticed as we watch these two aircraft fly, both of them are liquid fuel, and like gasoline, for example. And the advantage of that is that it is more energy dense than batteries. For every pound of fuel or battery, you get more power out of it. Another advantage of liquid fuel is that as you fly, your aircraft gets lighter. You're burning the fuel, and the fuel tank gets empty, and you actually gain efficiency as you go, whereas batteries, they basically weigh the same whether they're full or empty.
So coming up on a nice little milestone here for Extreme Aerial Concepts. They are approaching that 4th nautical mile where they will drop the weight. I'm excited to see how they bring it in, how they remove the weight, how quickly they can do it. Again, they still have almost 20 minutes, so that should not be an issue at all. There you see their altitude, perfect 167. looks smooth so far, JB. I mean, I don't see a lot of fluttering. The turns don't seem to be a problem. Their speed maintaining. I mean, they're going 40 miles an hour.
Yeah. They are smooth, no drama, and that's what we've seen from some of these teams. You know, some of the teams came in with a little bit more of a traditional design that they have tried to tweak to the current standard for payload to weight ratio for UAS all the way up to big helicopters like the military helicopters that carry Humvees. It's about a 1-to-1 payload to weight ratio. And that is surprisingly consistent across a lot of different aircraft. So they've taken this traditional design, which would hit a 1-to-1 payload to weight ratio, and they said, how can we find the secret sauce to tweak that and get it higher? Other teams coming in with much more innovative stuff, a little riskier, but with maybe better potential for payoff.
For people that might be turning in here the fifth day of the DARPA Lift Challenge and say, well, these aren't drones, these are just mini helicopters.
Well, the definition of what is and isn't a drone
is
a hot topic. The technical term we might use is UAS, Unmanned Aerial System. Drones, we're using it a lot just because that's the word that's in my head. But basically, it is a remote-controlled or autonomously controlled aircraft, a small aircraft without a human pilot on board. And that's why we don't call them the pilot, we call them the Remote Pilot in Command. RPIC is the technical name that they're using here at the challenge.
Okay, so we get our attention back on lane 11, Extreme Aerial Concepts. They are close to getting to that 4 nautical mile threshold. They will be cleared by the course marshals and told that you're good to go. Then they will come in and lose that weight as we are just 20 minutes into this first flight window of day 5 of the DARPA Lift Challenge. We're not too far away from the flight line, but I can't hear a thing.
No, I can't hear a thing. No, these are not very loud. Yeah. Maybe the wind is carrying it away.
This is true. Just to let you know, lane 3, H squared out of Boston, Mass. They are just hit the 3 nautical mile threshold, so we'll keep an eye on that as well. Maybe we'll spin back over to lane 3 once Extreme Aerial Concepts comes in to unload that 181.9 pounds. This is going to fly a little different. I asked you about this yesterday. This will fly a little bit different once they lose that payload, correct?
Absolutely. You might think it'd be easier to fly with less weight, right? Because obviously if you ask me to carry a 70-pound backpack or without it, I'll take without it. It's going to be easier for me. But these aircraft are very finely tuned. Their whole power system is based around the weight. And so you could imagine it being overpowered almost, and it can have stability issues or other problems.
Okay, here we go. So they have reached the 4 nautical mile threshold. They will wait to be cleared, then brought in. Now, this is when they can drop down, obviously, below 100 feet in altitude. So don't panic if you see them dropping down quickly and they go below 100. So they have been cleared. They're under 100 feet. So now they come in for a smooth landing. If this is the same pilot we saw the other day, get a load of this. This guy is just silky smooth.
Yeah, you notice he's bringing it in tail first, which might surprise you to see an aircraft flying backwards. And that is because the pilots are flying with what's called line of sight. The pilot has eyes on the aircraft. There's no camera. There's no video system. And he's just looking at it. And it's easier to control these RC aircraft if they're facing away from you, so that when you turn left, it turns left, and you turn right, it turns right.
Come on, look at that touchdown. There you go. So unofficially, 4.07 nautical miles have been completed by Extreme Aerial Concepts, and now they can unload that 181.9 payload. They'll go back up, and all that is left is 1 nautical mile without the weight. So from lane 11 to lane 3, this is H squared. They're at 3.65 nautical miles, so not much further for them to travel at 174 feet of altitude. Same thing, they'll wait for the clearance from the course marshals. They'll come in and they will unload their payload.
And while we're doing that, let me comment on the 2 different approaches that people seem to be bringing to the competition. As I said before, one sort of a more traditional craft that they've tried to tweak and find a special sauce, others more innovative. When we look at these more traditional craft, the principles that make them fly are relatively well established. And that's why we see these relatively low drama runs. The question is just, when are we going to hit that threshold where suddenly it doesn't work anymore? And we saw that yesterday when a successful one was completed, the helicopter tried to take off, it got a few feet in the air, and the rotor just separated from the additional weight. So these guys are more about the question of where will we hit that wall as opposed to can we do this at all?
Might have been the best quote of the day yesterday in that interview with Elaine, where he said, "We're pushing the limit to find the limit. We found the limit
We found
today."
the limit. That is right. That is right.
Certainly did. So we see H squared now. They are dropping down in elevation. They have come down to 76 feet in altitude. They will come in. They have been cleared. They will unload 161.9 pounds in payload, and that 54.7-pound vehicle will go back up and complete one more nautical mile. Now, their ratio is a 296. They're already in the top 4, so this should not put them, I don't think it's going to bump them up with that much of a jump. I think they're going to stay in that 4th position.
I would have to check the leaderboard for that. You see that little red ball there off the tail rotor? You guess what that's for, Todd?
I'm guessing weight? Counterbalance?
It's to keep that tail rotor from hitting the ground when you're bringing it in for a landing.
Oh, there you go.
Yeah, just in case you get a little sloppy on the landing. If that tail rotor strikes the ground, you're in trouble.
My guy right now, he does not look sloppy.
No, sir.
Look at this.
No, sir.
Dipped it down just to get everyone's attention. And going to hover for a second just to show off a bit because he can. Gives you an idea of the downforce that thing puts out.
Yeah, speaking of that downforce, there is a thing called ground effect. So you imagine that rotor blade acting like a great big fan blowing the air down. And when you're up in the air, it's pushing on the air. But as you get closer to the ground, it starts pushing on the ground, and you almost get like a hovercraft effect. And so it can actually be harder to fly close to the ground. You're lowering it. Suddenly it doesn't want to descend anymore. And then you have to sort of very carefully modulate the throttle to deal with that ground effect.
So this is extreme aerial. Drop it a few pounds.
Yeah.
Look at that. Just
chucking those weight plates. I feel like as a person of my age and physical capability, having to chuck those weight plates around would be a disadvantage to me. If I was on one of these teams.
You bring in Schwarzenegger and some of his friends.
Yeah, it's going to be me and one 25-year-old with muscles.
But that was a pretty easy jettison process there.
Yeah,
like they pulled out a pin and tightened it down.
Yeah, it seems like they're sliding them onto that pole. The pole itself is fixed, and they've got some kind of a pin in there to keep them. You definitely wouldn't want them sliding around. No. You don't want weight shifting when you are in the air. It can definitely throw the craft off.
So there's where they are. The time continues to run. They still have 12 minutes plus to go up and do 1 nautical mile.
Yeah, well, that won't be a problem. Time will not be a factor. You can see the fuel tank. They look like they're at about 20%, just by my eye, 20% fuel. So
is that straight gas that you pull into the gas station?
Well, sometimes.
Not rocket fuel, not nitrous?
There's various liquid fuels that could be used. I couldn't guess what the specific one they're using. Sometimes it is gas.
We're going to see Fast and Furious drone edition.
Yeah, notice you might say, well, they're awfully low in the tank. But again, you don't want to carry extra weight. And you're limited to that 55 pounds. That includes your fuel. So you're going to put just enough fuel on there to finish the run and maybe a little bit more for safety and not a drop more. So that's, if anything, you might look at that and think that's more fuel than they might have needed. Obviously,
but you look at the way of their vehicle, though. They're 54.9. They're right up against it.
Yeah, that's true. Well, they couldn't put any more. I'm saying perhaps they could have put a little bit less, although obviously they're making that call based on data that I don't have.
Back to lane 3. This is H squared. They are getting their weights off. I thought this might be one of those automatic jettison crafts, but not the case. This is a little bit of elbow grease to get this done.
Yeah, you could think with those plates hanging horizontally with the bar through them vertically, you could just like pull a pin and they'd fall right off. It does look like they've got a wooden stand. My guess is that it doesn't seem to be supporting the aircraft itself. My guess is that has something to do with supporting the weights as they're removed.
So the clock continues to run. H squared might be in a little better position as they're a pit stop at 15:32. We've got a lot of teams that are out on the flight line hoping to get their craft up in the air and get a qualifying run. Lane 2 is out there. I can't quite see who that is.
Yeah, it looks like they're preparing for their run. Again, the flight window is running, so whatever preparation that they're doing, of course, they know when the flight window is going to be, and there's a certain procedure for preparing your craft for flight. You bring it out, you fuel it, etc. If they're using their time to prepare, that's completely on them.
That was In Sky out of Miami, Florida we saw, and then this is Sherman Aeronautics in lane 14. This is one of the more interesting...
Interesting is a good word for it.
Two planes that spin simultaneously, chasing each other.
Yeah, we'll see that they're connected by a steel cable.
Oh, the Raging Cajuns are spinning up. That is in lane number 8. Looks weighted right there in the center.
Now, here's what's interesting about this one to me. We have these two rotors, right? And the question is, how are they achieving, I guess I would call it roll authority? So by making those, obviously those two rotors can lift the aircraft up, and by making one go faster and one go slower, they can tilt in one axis. But how are they tilting on the other axis? And it could be that they have a collective, or rather a cyclic, that is changing the pitch of the blades. But I don't, that's very
Well, you've got two options.
Yeah.
After today's broadcast, you can go over to the prep area and ask them, or you can take a trip down to Lafayette, Louisiana, at the University of Louisiana Lafayette, and ask them. Six undergrads that are running that program. They'd love to have you down there, JB. This is lane one. If you were with us yesterday to the very end, this was a team that was the last on the flight line, and then we had a little bit of rain come in. They got it for a second and then decided, you know what, let's not risk it. This is a squad from Foster City, California.
Notice how they're mounting the weight with that hook and strap. That's going to be real easy to disconnect.
Does it worry you at all with the wires there that are all exposed?
I would say that it probably reflects the amount of time that they had to prepare, and they're focusing on the things that are most important, but I would say that probably I would want to dress those wires a little bit if I had all the time in the world.
Okay. This is lane 10, Anopa out of Sanford, Florida. Small business in Florida and home to a group of engineers with a passion for building unique dual-use UAS designs. We'd love to see their crazy ideas take flight. We would love to see that happen as well.
Looks.
So here we go. Extreme Aerial looks like they have jettisoned all their payload. They are spinning up 1 nautical mile. They've got to stay above 100 feet, below 200 feet. And this would move them, I believe, into third place.
Yeah, and I don't want to suggest that anything's a sure thing, but I think this aircraft is not really under much stress now. And unlike some of the more innovative designs where the struggle is just to make it fly, and then if it flies, it will do amazing things, this is a relatively established design. I suspect that the odds of them succeeding here are quite high.
Quick correction, they would stay in second place, but they would improve their position with a slightly more ratio with more payload. So Extreme Aerial Aeronautics on their way. 4.14 is where they sit right now. Remember, they've got to hit that 5 nautical mile threshold while staying above 100 feet and below 200. And they've got 7 minutes to get that done. Should not be a problem, especially with the speed they're traveling over 20 miles an hour.
Yeah, and as they go to that speed, there's an optimal speed where they'll have maximum efficiency and control. So presumably they've optimized that as well. Sudden loss in altitude.
Ooh.
Sudden loss in altitude. Seems like the pilot has control again.
So what does that do to this run?
Did they get back in the air? Did they get back over the 100-foot threshold? Okay.
Still green. That's a good sign.
Yep, the run 6.
So that was before they hit the 100.
Yeah. So they were taking off again after removing the weights. They had a little bit of a bobble.
Yep.
I got to tell you, and you're not going to want to hear this, but sometimes in my life that has happened, like a fly hit me in the neck or something, and I went, like, just saying that doesn't have to have been anything mechanical.
Extreme Aerial now halfway through. And they are less than a half a mile, nautical mile away from hitting the 5 mile threshold. And things are looking good. 173 feet and holding. Still almost 5.5 minutes to get this done.
Yeah, just we're almost halfway through that last nautical mile. It's probably closer to the time than I would have expected. We've seen a lot of runs coming in the 17 to 22 minute range. Maybe the additional weight, we're taking it a little slower.
He's booking now, pushing 28 miles an hour. For a moment, they've dropped down now to 18, 13. And they are very close to hitting the 5 miles as they make a turn.
You might wonder why the weight affects the speed, and the answer has to do with G-forces. The heavier the aircraft is, the sharper you turn, the more the G-forces and the more stress is put on not just the airframe, but the rotor itself. So you might choose to fly slower, especially around the turns, as you get more weight on there.
Still looks like they've got plenty of fuel.
Oh, no question on the fuel. They're good to go. I mean, that may not look like a lot of fuel relative to the size of the tank.
Right.
But especially with the weight removed, this thing's sipping fuel. I would guess that they could fly it for 20 or 30 more minutes. That's just a off the top of my head guess. But
So 25 minutes has been eclipsed. They are at 4.97, make it 9.8. Why don't we just call it an even 5 nautical miles unofficially at 160 feet of altitude. So this will be a scoring run for Extreme Aerial Concepts. Run number 7 for them, and it will solidify their second place position. Remember, they bumped up that ratio just a little bit, so they are awfully close to hitting the 4-to-1 ratio.
yeah, they are over the 5 nautical miles according to the tracker. All they got to do is bring it in and land it safely.
How much do you think that we want to risk going for the 4 right now, or do you think they'll do another run and maybe go 3.8, 3.75?
Well, they don't have unlimited runs. Well, they don't have unlimited flight windows, right? So you really got to think, do I want to secure my current position, extend my lead, or do I want to take a bigger bite and try and break that 4.0? Obviously, that's a call that only they can make.
They've just got under an hour for this flight window, so if they're going to do something, they'll probably have to make it pretty quick.
Yeah.
As they bring it in. So Extreme Aerial Concepts kicks off day 5 of the DARPA Lift Challenge here in Dayton, Ohio. As they bring it in, and we have touchdown.
There you go. She's down. That's always a good feeling.
H squared right behind them, the team from Boston, Mass, and they have also eclipsed 5 nautical miles, going 5.03. And we'll see how smooth they are as they bring it down. Both of these teams just so solid, not only in their payload carry in the first 4 nautical miles, JB, but the last mile made it look easy.
Yeah.
And then just the capper on top. How smooth is this landing? I mean, that's just
Look at
cherry
it,
on top
big
material.
Punch to the shoulder.
Boom.
Everybody's happy. Everybody's happy when somebody succeeds. Whether you succeed or fail, they say here, failure, you learn from your failures, you gather data, so obviously success or failure is when you're pushing the limits. There's value in both of them, but obviously you're happy when you succeed, and you're happy when somebody pulls off a run and increases their number.
Culmination of a lot of hard work and late nights, and we've heard the stories throughout the week coming from these teams. Handshakes all around, success. Nice, very nice on day 5.
So the big question, as you said, is where do they go from here? They definitely have time for another run in this flight window. Their aircraft looks like it's in good condition. I think it's a given that they're going to go for another one. Going from that 3.0 to a 4.0, I mean, that's a big jump. And the question is just, do they want to try to get into first?
Sure.
If they did go for 4.0, it would mean a lot to be the first team to actually break that 4.0 threshold, but obviously you've got all these other teams nipping at your heels. It's not like everybody's going to stop competing.
So there is the updated leaderboard. Top 4 stays the same with H square hopscotching over the top of MacGyver. They go into 3rd place with that 296 that we just witnessed. Aviadrone's still at 384. Extreme Aerial Concepts 331, solidifying their position. So there are your top 4. They are all in the money.
That's right. They're eligible for half the prize by hitting that 2.0 to 1 payload to weight ratio, and they got to get to 4 to 1 if they want the full prize. I
Guess
mean,
Guess what comes up at noon?
What comes up at noon?
Aviadrone, the leaders. They'll be in that flight window.
I mean, I think you have to acknowledge that they're the current contender to break the 4.0 payload to weight ratio because they've come so close. I wouldn't be mad with a half of $2.5 million, Todd.
You could get over it.
I could be okay with it.
So I'll give you an idea what the flight line looks like and just how expansive this facility is here at the Museum of the United States Air Force in Dayton. This is the DARPA Lift Challenge, the Defense Advanced Research Projects Agency Lift Challenge. And there it is. Look at the museum in the distance, which JB and I both have on our to-do list while we're here.
Oh, yeah. So many aircraft in that museum. Historical aircraft, old fighter jets, and just all kinds of things from the development of aviation. And it's really cool to be here developing aviation. I mean, the Wright brothers launched an airplane. People said heavier than air was impossible. Now DARPA is asking for the 4 to 1 payload to weight ratio. And I mean, there are people out there who are saying it's possible. My first reaction when I heard about the payload to weight ratio was, if 1 to 1 is what basically every aircraft today tops out at, to ask for 4 to 1 feels impossible.
Yeah.
But we've already exceeded what I would have guessed was possible, and who knows where that's going to end.
Well, just moments ago in lane 10, the team from Sanford, Florida, Anopa Aerial. Look at the top of your screen. Can you see that?
Just that little
dead
dot.
center.
Yeah.
And now you can see it coming back to Earth
She's
quickly.
coming down. Yep. Not really easy to see what happened there or guess about why that happened. Maybe we may be able to talk to them later. But we know that little dot that you see, that's what the pilot sees, more or less, when he's flying or she is flying the aircraft. So it's a really specific skill set to be able to control the aircraft when all you can see is just a little dot in the sky.
Does that just raise the threshold of difficulty as opposed to what you do with the first-person goggles?
Well, I would say it does. Yeah, I fly with first-person goggles. It's basically like VR goggles. There's a camera on the drone. You have goggles on your face, and it's like you're sitting in the aircraft. And so there's never any question about which direction you're facing or what's in front of you. When you have line of sight flying, you can see around the aircraft much better, but it's harder to get precise positioning of that aircraft relative to objects in the distance. And then also, it can be easy to lose orientation. You think the aircraft's pointing away, but it's actually pointing to the right. And so when you turn left, it doesn't turn left. The really good pilots have almost like a sixth sense. They don't even need to see it. They just know which way it's facing. And they can do amazing things.
What did Donna say yesterday? It's a lot different as opposed to flying by the seat of your pants.
Seat of your pants,
literally.
Yeah.
Hopefully to get Philip Smith, call sign Donna, who is the program manager for the DARPA Lift Challenge, on the set with us. He was kind enough to lend us a little bit of his time yesterday. Made a few appearances. We told him we'd keep the seat warm. Meanwhile, if we go back to that overhead shot with the whole thing with Flight Fest going on in the distance, you see the RC planes going.
Yeah.
Just.
Wow. So the event, the DARPA Lift Challenge, is
cool.
co-located this year with one of the biggest RC flight festivals in America, Flight Fest. And we're looking off in the distance. It looks like they're doing some kind of a fighter jet fly-in. We got all these RC. Those are RC fighter jets, for the record. Can be hard to tell the difference on camera. And they are flying around, and it is just majestic. Just really makes you appreciate the beauty of flight.
RC radio control?
RC radio control, that's right.
Yesterday they had about, I don't want to say 50 or 60 of those up in the air, and they were literally doing a demolition derby.
Yep. They do a thing where everybody puts they'll have 70 aircraft in the air. They'll crash them into each other, and last man standing wins.
Oh, man.
Yeah.
That's cool stuff.
Yeah, it's pretty fun.
So we're getting word that Sherman Aeronautics is spinning, and that is the one with the 2 fixed-wing aircraft. Look at this.
Oh, my gosh. So they're connected with a steel cable. And the idea here, I mean, this just looks wacky at first. Like, what are you thinking? But the idea here is that if you think about a rotor, right, the inner part of the rotor is moving slower than the outer part. That's just how a circle works. Like, think about a penny on a record player. And so since the inner part's spinning slower, it doesn't actually make much lift, and it's just dead weight. So the idea here is we're just going to take the part that makes the most lift, the outer part. We're going to connect it with a steel cable, and we're going to fly these planes in a circle. You can see they've got the weight there attached in the center of the steel cable. It'll be more obvious when they lift off. I frankly, I don't even care if they complete a run. Just the fact that they made this, they had to develop custom flight control software for this thing to even fly. Like, to me, that alone is an accomplishment.
As opposed to me, this is basically my aviation moment of zen. It's just calming. It's like looking at a lava lamp. But these guys, it's just such a cool design.
I want one of these as a desk toy.
Exactly. Tell me there's a better screensaver out there. No way.
Oh, my gosh.
But look at that cable and the connection there. I mean, that is obviously the most critical point of this design.
That's right.
If that fails, no go. But yeah, they're just.
Well, it's interesting you say that, because if that fails, like, theoretically, each of these is an independently flying aircraft. Like, you imagine that they would just whip off into the distance. I could imagine a scenario where the flight controller detects that failure and puts the planes under autonomous control, or lands them, or does something else.
I was going to ask you this yesterday, and you talked about the autonomous controlling, and when Donna was on the set with us, is this a potential if it did break free or something like that? Are they separately controlled?
I mean, it's possible. It's possible.
Each
right now,
one independently flown.
Yeah, my understanding is right now the pilot has a single radio control link and is flying this system as one, as if it was one aircraft. He told me when they initially prototyped the idea, him and his father were manually flying both of the planes separately, and they just had to coordinate with what they wanted to do.
There's the good folks from Sherman Aeronautics, Southern California-based family business out of San Bernardino.
Yeah, so that pilot has a controller in his hands. You can see it there. And when he raises one of the sticks to make it climb, the two airplanes together climb. When he tilts one of the sticks to make it go left or right, the two airplanes together using their flight controller. That's a little computer that basically manages the flight itself.
And it looks like they are picking up speed.
And picking up altitude and picking up the weight. Another interesting thing about this design is you can see that that weight is pulling down on the center of the steel cable and tending to pull the aircraft into each other. What they do then is they just increase the speed of the aircraft, so they pull outward harder, and they can actually precisely control that angle and how much the weight is pulling the aircraft together.
Interesting to see how much weight that is, and we'll see if this is actually a competition run. If it is, you'll see the top right corner of the screen will go green, and then we'll be able to give you the numbers, but they're going to set it back down. So maybe just didn't feel it quite right. This seems like it's more technical in this sense that it's almost like not one but two drones.
Yeah, so there's several things about this that are challenging. One is just the physics of having the two planes acting as one. The second one is that weight is tethered, and when you have a tethered weight and it's not fixed to the airframe, it can dangle, it can pendulum, and anytime you've got a significant amount of weight moving back and forth on an aircraft, it creates challenges in keeping the aircraft under control. So we haven't, to my memory, we have not seen them actually, we've seen them take off, we've seen them kind of fly around, we've seen them land. We haven't seen them actually go down range and move.
Make the turn
in
and
sort
come
of a
back
meaningful sense.
Yeah. So meanwhile, Sherman Aeronautics, it looks like they are back up in the air again momentarily. This is over to, I believe, lane 1. Hanamontum, we saw them yesterday at the end of the day, day 4. A little bit of rain came in. They had to suspend. So this is the team out of Foster City, California, Silicon Valley. So I look at this, and I already commented about the aesthetics of just the loose wires, which I'm sure these guys are coming. That weight looks awfully free.
Yeah, it's
free
dangling.
flowing.
So dangling it from a strap like that makes it easy for them to attach and detach. They just have to run that webbing through there and clip the hook. The downside is that it is going to swing, and the aircraft is going to have to stabilize itself around that swing. The aircraft has, I talked about the flight controller, and in the flight controller there is an algorithm called the PID controller. We're definitely not going to go into what that is. But the PID controller's job is to stabilize the aircraft, and when parts of the aircraft move, the PID controller, it's like, okay, here's what I need to be doing, and then something changes, and it can't really adapt. They have to manually tune that, and so when that weight is swinging, that can really throw the aircraft off.
So there you see the pilot in relation to the landing area. It looks like they are going to bring this back down. Hanamontum, nice gradual descent.
Good, smooth,
It's a little
slow.
half weight check.
Yeah. We've got 8 motors on this one. That is a coaxial octo. Octo because it's got 8 motors. Coaxial because the motors are aligned one on top of the other. The advantage of the coaxial layout is that the drone's a little more compact, and the propellers can be larger, which sometimes can increase efficiency. The disadvantage is that when you have 2 propellers in line with each other, one of them is kind of getting the air from the other, and they don't make quite as much thrust. That lower propeller is losing about 30% efficiency compared to if it was on its own.
And just next door to Hanamontum in lane number 2 is InSky out of Miami, Florida. And this was there moments ago. Lift, and did they keep it level? Boy, that's
not ideal. When it takes off, you want to see it just lift off, stay stable. When it takes off and immediately cocks to the side, it means one of 2 things. Either it is a little bit out of control, or the pilot's just doing something. You could take off and do it on purpose.
The good news is, since it crashed or set down hard so close to their area, they are able to retrieve it. Had that been another 50 yards out downrange, they could have just sit and wait out the last 40 minutes of this flight window.
Yeah, for safety reasons, no one's allowed out onto the field while aircraft are in the air.
Makes sense.
So, clearly.
So we are getting a little bit of breaking news, inside knowledge that H Squared is adding weight. So this is a team that's in 3rd place. We saw them just moments ago complete a full run. 296 was their ratio on weight, and they're feeling pretty good about themselves. Someone ate Wheaties this morning. They're going to go out there and get the Olympic try.
I'm curious to see whether they're swinging for the 4.0
Look
and
at
trying to take
That's
first place.
Serious weight.
I'm counting. Well, I think I count 3 plates.
I count 4.
You count 4? Well, we'll know as soon as they take off.
It's like you at dinner last night. You had 4 plates, didn't you? Appetizer, dessert, main, and something else. Which, by the way, can we give a little shout out, a little love for Dayton?
Oh, man.
They've been great, haven't they?
Dayton's been great.
Dayton's been great.
Absolutely.
Good folks of Dayton, Ohio, welcoming DARPA Lift Challenge everywhere we go. What's this DARPA Lift Challenge? What's this? I'm like,
yeah, we've had so many of the public come out, and if you are in the Dayton area,
yes,
the challenge is open to the public today and through the end of the event.
This weekend, come on down to Flight Fest. You can watch the DARPA Lift Challenge. You got some great food cards out here. I mean, this is a good weekend here in Dayton.
Yeah, we got.
So this is just a little moment ago. Alpine Combat out of Fountain, Colorado, got up in the air. It does not look like they were weighted, and they came down quickly, side by side. Save. Relatively easy touchdown. A couple pieces might have come loose.
Yeah, I mean, you look at that, and you see that the airframe itself, they might have broken off one of their landing struts, but the airframe itself is relatively intact, and there's pros and cons here. This style of airframe is pretty robust, so you got a little more weight, but it's going to survive a crash like this, but hopefully, and let you make another attempt.
Right.
We've seen some airframes that are much lighter and much more spindly, and if they were to experience a crash like this, then they probably would not be going up again.
Replacing the rotors, though, not a big issue. I was in the prep area and saw some of these guys, and they had I'm going to say buckets full, but they had a lot of spare rotors.
Spare props. And I want to correct you there, Todd. There's no way you could know this, but in the drone community, we say props or propellers. Mm-hmm. If it's a helicopter, you call it a rotor. And if it's a drone, you call it a prop. And only drone people will, but if you want to sound smart, you say props.
I have never sounded smart, but I appreciate the intel.
So I would call those props.
Props, okay.
Okay.
So it's like a boat prop is what you're saying.
A prop, that's right.
Okay. As opposed to a rotor if it's a helicopter looking.
Yeah.
Let's cruise over to lane number 8. This will be the team from
So we would call this a
Lafayette.
rotor.
No.
Because it's a helicopter.
That is a rotor, not a prop.
We call it a rotor.
Now you're just trying to mess with me.
I am.
Raging Cajuns. Do you know what a Raging Cajun is?
What is a Raging Cajun?
No real idea, but I think it's the people that are from the area of Louisiana. They're known as Cajuns, and yeah, it's a colloquial term for the University of Louisiana Lafayette. These guys were a GoPro the other day, but this is 6 undergraduates from the University of Louisiana Lafayette, the Raging Cajuns. They gave us a little bird's eye view. How about this? See, this is what we need to see.
Checking the battery.
Look at that. That's up close and personal.
Keeping it covered.
Mm-hmm.
Keeping it from getting too hot, I guess. The heat definitely, the sun definitely could affect the performance of the situation. We've got some first-person view here from GoPros.
This is like if you were wearing your goggles.
Being worn. Yeah, that's right. Being worn by the team. Carrying it out.
The next step we have, you know what we need to get on these guys?
What's that?
Microphones.
Microphones.
I want to hear what they're saying every single time.
I'm not sure I would. I bet.
Maybe when they put a hard set down, I might want to hear it. But the team from Louisiana Lafayette, the Raging Cajuns, doing a little pre-flight prep. Looks like they're.
And
is that the Titan?
I believe that is the Titan. So
the
Titan is the system that's being used to track the aircraft's location. When you see that the aircraft is at a certain altitude or a certain distance, the Titan tracker is what's doing that. Of course, that's also used to track the aircraft's location and make sure it is staying within the safe geofenced zone.
Plus, it gives us all that great data, correct?
Yeah, and that Titan, it weighs about 2.5 pounds. And I believe, we've had some debate about this, I believe that's counted toward the payload weight. I talked to Donna this morning, and he said...
Not the aircraft weight.
When you see that an aircraft takes off and it only has 2.5 pounds as its payload weight, that's the Titan tracker.
Copy that.
Well, the thing I just noticed is looks like they have put it into a container the shape of a weight plate, so it fits right on that stack.
If you're just joining us, we want to welcome you to the National Museum of the United States Air Force for the DARPA Lift Challenge in Dayton, Ohio. Todd Harris alongside Joshua Bardwell and Elena Buenrostro. Here's our current leaderboard as we are all trying to get to the 4-to-1 ratio. That is the goal. Aviadrone leads the way at 3.84. Then it's Extreme Aerial Concepts 331. H-squared at 296 and MacGyver at 251. They are in the money, $2.5 million to the winner if they can get that 4-to-1 ratio completed. They have to go 4 nautical miles with the weight and then 1 nautical mile without the weight. And that's how we will determine the champion. And there is the breakdown. On top of the top 3, and we've got the lovely trophies on the set here with us, we've got 3 nice little, I don't want to say they're side consolation prizes.
Subjective.
$500,000 is not a consolation prize.
No, sir.
These are subjectives.
That's right. Yeah, I think the idea here is that the first, second, and third place get the bigger prizes, but people are going to come with unique ideas, and the purpose of this is not just to see who got the highest number, but to have all these ideas come to one place, percolate, share, intermingle, and the idea here is that we want to be able to reward those as well.
We had rain earlier today here in Dayton. There we are, and the rain has cleared. Todd Harris, Joshua Bardwell. These are the trophies we were talking about.
Yeah.
These are nice, but I think the cash prize is probably
Of course,
a little
of course,
nicer.
of course. And hopefully the teams will be able to use that money. Well, number one, to compensate themselves for the expenses. A lot of these are self-funded. They're small businesses or small families. And then to take that and expand their business and spin this into something even bigger.
You have 400,000 YouTube subscribers?
Around about.
Wow, now you're just showing off.
More.
You're rounded down, I think.
No.
Yeah, to your point about those putting money out of their own pockets, I talked to a team from Coeur d'Alene, Idaho, talked to a team from Flagstaff, Arizona, not around the corner, drove out here.
Yeah, from
made
Flagstaff.
the drive 25 miles straight through or made one pit stop and came flying in, and that's dedication.
Yeah. These teams really want to be here. I spent some time in the hangars talking to some of them individually. I wasn't able to talk to all of them, unfortunately. Right. And one thing I took away was people were showing up who, for various reasons, technical, financial, logistical, they knew that they would not, maybe they wouldn't even be able to compete. They couldn't even take off. Some of them knew that they would be able to take off, but they knew they didn't have a shot of hitting the ratio. And they still wanted to be here. They still wanted to spend time with the other teams, see the ideas, and just experience the event.
On the flip side of my story about those who traveled from places like Coeur d'Alene, Idaho, and Flagstaff, Arizona, the team from Maryland, you hear about them?
No.
Had a little bit of an incident. They drove home. They drove back to Maryland, repaired it, and came back, and they're here today with us.
That's a long drive.
That is a long, quick drive. I'm sure they kept it well within the speed limit. But H squared is adding a little bit of weight to see if they can go back up. Remember, we've already seen them up today. They've got one run in today that was an absolute thing of beauty. But the big question is, how much weight are they going to push onto that aircraft, and will they go for the home run hit? For me, I'm a Vegas type guy. I say roll the dice, hope it comes up Yahtzee.
Yeah. You certainly, sitting here in the booth, it's easy to say, well, I want to see them go for 4.0, but like if they take off with too much weight and the rotor head explodes, maybe they wish that they could have secured second place. That is a really tough decision. I'll be so excited if I see that 4.0 payload to weight ratio.
So what you're basically just saying is don't listen to Todd. Do what's best for you.
No, I'm just trying to.
Because the guys who made squared are from Boston. I don't know if they could drive to Boston and get back in time for tomorrow.
No. Yeah, a lot of these teams don't. If they have extra aircraft, if they have spare aircraft or spare parts and they can repair it, they can continue to compete. But we've seen teams come and they basically have a 1 of 1. And so they have to sort of inch their way up the leaderboard, and they really have to manage the time and opportunities they have relative to the risk that they overstress their airframe and are no longer able to fly.
And I guess that brings us to the next conversation point that I wanted to bring to you, and we're going to have hopefully some guests with us join us on the set here at Flight Fest at the DARPA Lift Challenge, is if you have a high-tech, expensive frame, that's awesome. And more power to you. If you have something that's low-tech and inexpensive, like we saw with our friends yesterday after the show ended, they were more than happy to show us all their backups because basically it's an inflatable.
I hope we're able to get them on the air.
Oh, so good.
It is an inflatable. Like think about a bounce house with a fan blowing into it.
The guys from Illinois.
This is not like that. I got to touch it. It is remarkably rigid.
Harder than we thought.
And it's an inflatable frame. But
it weighs nothing. I mean, literally.
Weighs nothing. Yeah, it's wild. He said they could get that up to, UAS are divided into groups, Group 1, Group 2, and Group 3. Group 3 is the largest, and he said they could do a Group 3 version of that inflatable frame.
So this is H squared. They continue to, looks like they're putting fuel in at this point, and that is, JB, that is a lot of weight, and I'm going to say I'm right. That's 4 plates.
I think you might be right.
That is a Joshua Bardwell Dayton dinner situation.
Yeah. And we see the gray box on top of the plates. I believe the Titan module comes in 2 form factors. I've seen one which is that small gray box, which you can't see it at this moment because the official is standing in front of it. But the other one appears to be a larger weight plate sized one. I'm not sure about the logic of when one is used versus the other.
So there is the gauge to measure just how much weight they have, and they're going to measure every single thing. So there's the weight. And that's because they've just put the fuel in, correct? So they want to make sure they're obviously not over 55.
Yep. That makes sense to me. If you have batteries, the batteries weigh the same every time. When you add fuel, and that may be how they hit that 50 54.9 pounds.
Yeah, yeah.
They just add fuel till they hit exactly 54.9.
So that's the only variable it should be on that drone,
yeah,
correct?
For sure. And it does also look, I've seen them how they're loading the weights. They set the weights on a stack on the boards, and then they set the aircraft down on top of the weights, and the shaft goes through.
You know what a wise man taught me?
What's that?
That's a rotor. That's not a prop.
Did I say prop? No.
That's a rotor.
That's a
That's
rotor.
not
That
a
is
prop.
correct. That is correct.
That wise man would be you.
That is correct.
All right, so we continue to watch H squared. A lot of activity out on the flight line here. Day 5 of the DARPA Lift Challenge. More weighing going on. This is got to be precise when there's this much money on the line. You do not want to miss it because you had 3 extra ounces of fuel that you did not need.
Yeah, don't want to get disqualified. I mean, realistically, the officials simply would say, no, you can't take off, you're overweight.
But they're going to check, double check.
Yeah.
This is one of those measure twice, cut once situations.
Yeah. And I've been really impressed with the work that's gone in from the officiating team, from the staff, to make sure that everything is fair and consistent, and the rules are applied equally.
Can we give a little love to the DARPA folks?
Safe.
How great have they been? I mean, this whole setup has been
fantastic. One of the things, I mean, they're not only are they doing their jobs, but they're also just so enthusiastic and excited about the challenge. Everybody from the organizers all the way at the top to the individual people with the orange shirts down at the field.
Yeah. Tip of the cap to all the folks in the orange shirt. We appreciate what you've done, what you've put together. This is a massive undertaking. I think there is not another white tent in the state of Ohio because I think they are all here at the DARPA Lift Challenge right now. They just haven't missed anything. I mean, people are being taken care of. There's plenty of hydration. There's plenty of space, plenty of parking. It's been fantastic. So thank you. There you see the flight line, and there you see all the different lanes. Gives you an idea of just how massive this facility is. It looks like Sherman Aeronautics is up again.
We can see those 2 planes
That is not
circling.
2 seagulls battling.
Yeah. I'm just doing a little hover test.
Okay.
And you can see the spacing between those lanes, which is designed to ensure that the drones don't interact with each other and that they stay safe and within the expected location.
I guess that's another practical application, right? I mean, you can't have a drone that takes up that whole area. You've got to be pretty precise in your lanes.
I mean, if you think about it, if you can't stay on a line within a certain altitude, then
we can't release you into the public.
No, absolutely.
And there's a look down the flight line. So again, several crafts are out there. No one other than Sherman Aeronautics right now, to my untrained eyes, is up in the air or even moving. But we're hoping to see H squared possibly go up.
You know, I can't help but look at the clock. How much time is left in the flight window?
I've got unofficially, and I'll get barked at if I don't get this right, but I've got unofficially 28 minutes.
Now, we know that sometimes the flight window is extended if a team lost time for some reason that the officials judge wasn't their fault. They may extend the window, but one of the things...
This looks like we're going to get hot here in a second here, JB.
Oh, yeah.
Weights on, fuels in. H squared, their pilot. Come back and check one more thing. H squared currently sits in 3rd place, 2.96. We'll get you a official weight on that. So 3.32 or above gets them into 2nd place. 3.85 or above puts them in the lead. 4.0 above gives them a big slap on the back and a big fat check.
So what I see there is that he disconnected, I believe that is essentially the spark plug.
Okay.
He disconnected it. That would not be something you would do if you were getting ready to fly. The other thing I saw is that he was kind of looking at the aircraft and fiddling with his controls. Now, that could have been just a regular pre-flight control check, but also it could indicate that something isn't behaving how they want it to behave. Yeah, that's not encouraging.
Yeah, it looked like it was all systems go, and then it was the, as you pointed out, detachment and reattachment, so something obviously is not to their liking.
Yeah.
And now I know what that red ball that's hanging off the back does.
So a lot of times with these liquid fuel engines, that's the last thing you'll do before you're ready to fly.
Is hook up the spark?
Yeah, you'll do because for safety reasons, you can't fire the engine without that connected.
Right.
So you'll do all your pre-flight checks with it disconnected. You'll check your control surfaces, everything that you need to do. And then the last thing you'll do is you'll connect that quote-unquote spark
Here we
plug.
go.
And you'll be ready to go.
All right, while they go through the final checks on H-squared, we hope to see a flight. He's just given a thumbs up, so that'll give us an opportunity to check in the prep area with Elena. And she is with Extreme, and they had a very good run today. Elena, what did you find out?
Hey, Todd, I'm here with Peter, and you are right. They had a good run right now. Peter, tell us what happened.
Oh, it was very good for us. It's actually the third run we are doing since we are here. It's great to be here. I'm so excited. We secured second place once more, so we stepped up by another 20 pounds. So actually we are carrying 180 pounds.
Our apologies there. A little bit of a technical breakup with Elena. That was Extreme Aerial. There's their drone. Again, he mentioned that they have secured a tighter position or a tighter hold on second place. So they are certainly trending up. Let's give you a couple shots of this. JB, you can break this down. There's not a lot to criticize. This was smooth from start to finish.
Yeah, this is their run, replay of their run from earlier. They're putting them in second place, keeping them in second place at 3.31. And these more traditional rotorcraft, we know that they'll fly. And the question is just how much weight can we make them carry? And as we saw, you just keep adding weight until eventually you hit that limit and something breaks. And they have not hit that limit yet.
Didn't look like there was any wobbles. Didn't look like there was any problem on the turns. The landing was, man.
But that suggests possibly that they've got a lot more to give.
Yeah. So a slow and steady approach, it looks like, is the plan for Extreme Aerial, the team out of San Jose, California, as they bring their squad in here. The Aerial Concepts provides UAS integration services for remote sensing science missions.
Notice they've removed their rotor blades.
Yes.
You see that? So we've got the rotor head, and of course those are removable for transport, for example. You wouldn't want to put that gigantic rotor in your car.
And is that for transport as well, as far as getting back to the prep area? And
perhaps, yeah. It's pretty big.
I guess
don't
what I'm
know
leaning
exactly
towards
how
is
big.
that mean they're probably done for the day?
Maybe. Maybe.
This is H-squared. We saw them just seconds ago. We thought they were going to go up. They didn't. They detached. They got it up again, and here we are. And this is can't wait to find out how much weight's on there.
Yeah. They completed a run earlier, and here we see
81. So look at this, 335. So it's green. They're above 100 feet.
So we've got green in the upper right where it says run 7. Tells us this is an official scored run. They are going for it. And that 335 ratio, what would that do to their standings?
I think that 335, I will not guess. They're currently in third. I'm going to crunch some numbers from my abacus. This would move them into second place, GB. So I did a quick math in my head there, and they would move into second place. Use my Mandy abacus. And so they're at 335 with 181.9. Their vehicle weighs 54.3. So that's why they were so close to 55. That's why they were so fastidious on how much fuel they were putting in. Now, this is what's interesting. By my calculations, the flight window is still open for 23 minutes. They're 1:30 into that, so they should be able to come back down. So all that great insight that we were just providing has gone nowhere.
Wow, they surely had a good reason for coming down.
Yeah.
So for example, if you're adding weight, and then as the pilot you find that you are much higher in the throttle than you think you need to be. Obviously, if that aircraft hovers at 20% throttle, it's got a lot of power to give. And if it hovers at 80% throttle, you have almost nothing left at the top end. So for example, that might be a reason why a pilot might turn around and come home. I'm seeing fist bumps. They seem happy with the result.
Is it a case of sending it up with that weight? What kind of data we got off it?
Maybe.
Hey, we can actually put a little more on there.
Just because we see green in the upper right, that means it meets the criteria of an official run. It doesn't necessarily speak to the team's intent. Also, they can set down and they can just take off immediately again and start another run. Again, as long as they're on the ground by the end of the flight window.
And there's no opportunity for me to put you or Elena into a golf cart, send you down there and ask them what they're going to do?
I would love to do that, but I'd rather be here with you, Todd.
Oh, there you go. There's a true partner for you. So they will wind down, and that looks like they are done for this flight window. Remember, it's a 90-minute flight window, and by our unofficial calculations, there is 22 minutes still to go, and that's about the threshold that you need to get a
a complete run.
A complete run in
Yeah.
and go full green.
Yeah, you see that rotor head slowing down. Of course, they could just spin it up again, but especially with the gas engines, you'd usually leave that idling if you intended to fly again.
I would say by the handshakes and the fist bumps, I think they're pretty happy with what they got done today. A lot of great work, a lot of great R&D, intel.
Yeah.
Yeah.
And they know it'll fly at that higher ratio, that payload to weight ratio. Sadly, now they got to take the weights all off again. You wouldn't want to carry that whole thing.
Okay. So it looks like they're going to come out and jettison those 4 plates and then take their craft back to the prep area. Another good look from our cameras from the flight line. Not a lot of activity going on right now. I do not believe anyone's in the air, and I do not believe Sherman Aeronautics is spinning down there at the end, so possibly they have come off the flight line as well and called it good for this flight window. Remember, we've got another flight window coming up at 12 o'clock Eastern time from here in Dayton, the National Museum of the United States Air Force. This is the DARPA Lift Challenge. We'll see how things go. Mother Nature has been a little quirky this morning. We had to push back the start of today's competition by 1 hour, but no harm, no foul.
Beautiful now.
Perfect right now. A little bit of a breeze blowing. You see Flight Fest going on. They've got the RCs up in the sky. Fans enjoying a nice breeze blowing across there as we get a good look at the entire facility here at the United States Air Force Museum. So we'll keep an eye on that flight line. Someone could still spin up, surprise us, decide to go up, maybe do a half weight check.
Yeah, we see a lot of teams who are using their time not to make full attempts, but
Sure.
just to gather data. It's worth pointing out that it would not be legal without a lot of paperwork to fly an aircraft over 55 pounds in the United States. So we saw people coming out. They built their aircraft. Their aircraft is under 55 pounds, and then they put 200 pounds of weight on it. And because of the special waivers that have been granted for this event, some people came out here just because it's the easiest way for them to legally test their aircraft at these weights. And if they win a prize, so much the better. But we definitely see a lot of people doing work out on this field, even though they're not making an official attempt.
Yeah, Raging Cajuns taking advantage of, they've still got 20 minutes to maybe get some more data off their craft. They put it up, they'll take the rotors down. Since we have so many smart people here, we've sorted out the problem with Elena, and she is back with Extreme Aerial. All right, pick it up with where you were, Elena.
Hey, Todd. So, as I said, I'm here with Peter, and they just had an excellent run, and he's going to tell us all about it.
Oh, yeah, it's the 4th run since we are here. We flew on Monday, on Wednesday, and today. And we are actually trying to secure place number 2. I hope so. We were carrying a lot of load now, 180 pounds, and as far as I know, it's the most what was ever taken airborne. So we are really excited.
And Peter, what would you say is a contributing factor, a part of your design that really is helping with the success that you guys are having right now?
Okay, we are actually the turbine guys. So I'm passionate with conventional turbine design. We produced our own engines. It combines a turbine engine, which is very small, has a lot of power, and got the gearbox in it. So there's a patent on it as well. So I think it will be very interesting for the crowds because there's a match between classical turbine power that runs on Jet A and all electric teams. So we will see how it will work the weekend.
All right, we are wishing you all the luck. Thank you. Back to you, Todd.
All right, thank you, Elena. They are part of Jakadovsky Jet Engines. They were established in '85, and they perform repairs on full-scale helicopters and manufacturers, custom turboshaft engines, and integrated reduction gearboxes for UAVs. So, bottom line, smart people. All right, here's the current leaderboard right now. Top 4 as we are coming down to the final 15 minutes of this flight window on day 5 of the DARPA Lift Challenge. Aviadrone, still the leaders. We saw them yesterday put up a 3.84 ratio. Oh, so close, JB, and that gave us all kinds of thoughts of what is possible. Yes, I mean, they were right there.
Yeah, when I first heard about this competition, I looked at what aircraft were doing, and we're basically quadrupling what current aircraft tends to top out at. And I said, well, that's impossible. And then I started thinking about it, and I thought, well, maybe asking for things that are just barely sort of not impossible is exactly, well, obviously, DARPA's mission is what it is. But and so now to see someone get so tantalizingly close to that 4.0 payload to weight ratio, but not quite crack it, I'm on tenterhooks. I'm not sure whether I'd rather somebody break it today or just keep me in suspense until the last minute.
Exactly.
No, I do know the answer. Hold on. I know the answer. I want someone to break it as soon as possible because then People start
go
shooting
farther.
for 5.0,
Yes.
6.0.
Good
I want to
point.
see how far we can go.
Good point. Hannah Monton there from Foster City, California. We've seen them out on the flight line. One of the teams that got out there immediately, going to use their whole 90 minutes. They've been given an extra 5 minutes. So by my unofficial calculations, they've got roughly 20 minutes.
That's right.
Which is right on the verge or the limit of possibly getting a run in. But they might be doing just a half weight check.
Yeah. Bear in mind, as we've said, that there's a lot of use for this time other than doing full attempts. I think with the time they have remaining, it's not, especially as they're not currently ready to fly.
And as they continue to make their small tweaks there, and it looks like they're pulling away from this, we might see them get up in the air. Do you think the majority of the drone community shared your opinion of the 4-to-1 ratio of it's impossible?
You know, I would say, and I actually have a little bit of unofficial polling data because, of course, I make YouTube content, and every time you put up a YouTube video, the comments fill up with people who share their opinion, and it kind of gives you a sense of the waters.
If people want to go to your content, give them a shameless plug. Where do they go?
Joshua Bardwell, my name. Yeah, just search that on YouTube. You can find
Go to his YouTube channel. 400,000 plus followers.
Thank you. That's true. But I'm humble about it. I think that the general sentiment was that this would be very difficult or impossible, and there were a few people who said, "What are you talking about? That's too easy." And I thought, well,
too easy.
I know, and I thought, well, if that's too easy, why has no one done? Number one, why has no one done it? And number two, if it's so easy, great. We'll get 70, 100 competitors out here, and they'll all blow that 4-to-1 out of the ratio and keep going, and we'll find out what the limit really is. So either way, this is a win.
Okay. I don't want you gloating on Monday, but I would love for you to gloat on Monday. Too easy. So, Hannah Monton, here we go. We'll see if they can get up here and use this last 20 minutes or so they have. The group out of Foster City, California, Silicon Valley. They build a few things in Silicon Valley, don't they?
A few things.
Yeah.
A few things. Yeah.
Mostly people down there.
Mostly computers. It's one of the challenges with this type of thing. You know, you ask me, I'm a computer guy, and then I got into drones, and now I have to build drones. I have to learn how to solder. I have to learn how to build actual physical objects, and that is a whole separate challenge. It's great to see the different disciplines that are in each of these teams. You'll have a mechanical designer, an electrical designer, a computer programmer, and they all come together, and you really need all of those skills in order to make something like this work.
All right, we're just waiting for the rotors to spin up here at the DARPA Lift Challenge. Todd Harris alongside Joshua Bardwell. Elena Buenrostro out on the flight line, the prep area, getting us all the intel, talking with some of the teams. We'll be here until Sunday, and the weather looks pretty good. There's some weather possibly coming in later this afternoon, but I think it's after we're done and off the air. Then we've got Saturday, then we've got Sunday. I think Sunday's going to be amazing.
Yeah.
I just have a feeling Sunday, it's like, well, we can go home with a fully intact drone, or we can just shoot for the moon and go for this thing.
I dare, and obviously all safety in mind.
Right.
Nobody here is going to say, I'm good. Everyone is going to keep trying.
Went home with everything
until
intact.
they find the physical limits of their. And you'll see that with hobbyists as well. You know, when we go out and we fly drones, we try to do difficult things and we crash. And as long as that drone will get back up in the air again, we're going to try again. If you go home with all your drones working, it wasn't a complete day.
Just so you know, Joshua and I have no vested interest on who wins, but there are some teams that we really enjoy watching. Spitfire, if you were with us yesterday towards the end of the broadcast, interesting.
Yeah.
They'll be going at 2 o'clock Eastern today. If you don't come back for anything else, come back because I want to see
what's... Looked like a freaking spaceship, rocket ship.
It looked like something that Batman would use to get to
Mars.
It
looked like the Bat plane.
So Spitfire, hashtag the Batman aircraft, it will be back out on the flight line, and it got a lot of people's attention yesterday.
Yeah.
People were pretty excited. Donna was excited about seeing what they were going to do.
A directed thrust turbine or jet, and they had a little bit of a problem. It looked like they melted.
It got warm.
It got warm. I heard a rumor that they had an original frame made of carbon fiber, and then something happened to it, and they had to 3D print a frame.
Oh, my gosh.
And then, obviously, plastic melts a little easier than carbon fiber, and that may have been what caused the problem.
Yeah, that was a spicy moment yesterday.
Yeah,
we were all excited about that. If you weren't with us, here it is, by the magic of television.
Yeah.
There is the craft we're talking about. That is, it's not the Batmobile, it's not the Batcraft. That is Spitfire.
Yeah, I don't know if we have a before picture, but you can see the little nubs at the bottom, and the motor is actually resting on the wood. Originally, it was elevated 6 or 8 inches, and the heat from the engine just melted it. But, I mean, these guys are not giving up. They broke their frame. They didn't say we're going home. They 3D printed another frame. And maybe someone in that room said, it'll melt. And someone said, well, let's try it. Let's go for it. Let's see if we can get it in the air. And they did, and it didn't go in the air, and now they know. But nobody's going to quit.
Again, 2 o'clock today, 2 o'clock Eastern time here from Dayton. Spitfire will be back out on the flight line. We hope they've sorted everything out. We hope they've replaced the melted parts, and we hope that they get it up in the air because everyone wants to see what that will do. It's just a different aircraft. It was one of those things that was like, wow, that is really cool. And of course, we had Donna here, the program manager, and he's a guy that has flown Harrier jets, so he doesn't get too excited about much. He was pretty excited about seeing this thing. This was the position of the aircraft, and so look on the right as opposed to what you see on the left.
Right. I love how the left picture, the after picture, has like a guy with his hands on his hips going, well, that didn't
It's a little shorter than it was before. They also, I think, are going to be charged for a hole that they burned into the landing pad wood because they just.
I'm sure that's in the budget.
Kidding. We'll just patch it with some duct tape.
Yeah.
So Spitfire, 2 o'clock. We'll have that for you. Obviously, want to let you know that coming up, we're down to less than 10 minutes to go. We'll have another flight window opening up at 12 o'clock Eastern time. We're with you all day here from Dayton. This is day 5 of the DARPA Lift Challenge. There you see still looks like 3 teams on the flight line.
Yep, 3
if I'm not
teams.
mistaken. 1 team that's forward, 2 that are set back a bit.
Yeah.
A little bit of activity, but that's H squared. Looks like they're packing up and heading home.
And you might say, well, we've got 14, 15 flight lines, only 3 teams out. I mean, some of these teams, for whatever reason, weren't able to make it. Some of these teams who were scheduled might have crashed out, run out of drones, and not be able to continue to compete.
Yeah.
I know that one of my concerns as I thought about this was, like, what if everybody just crashes in the first 2 days and that's the end of it? And I'm really happy to see how many people are still in it, still competing, and still trying. And we've really proven which of these designs have the legs and which of these designs maybe need a little bit more refinement.
Okay, so it looks like they are doing a little bit of putting a pin in the rotor. Oh, we got the Raging Cajuns squad from University of Louisiana Lafayette doing a little more testing. Does not look like they have weight on their JB.
Yeah, we can see the Titan module, that gray circular plate. That's the tracking module, and then I think there might be a plate on the other side, maybe just for balance. You can see that with the aircraft having these 2 rotors in a line like this, it may not have as much authority to rotate along that axis. And so you would definitely want to keep that weight centralized.
Isn't there a military helicopter similar to that has a double rotors?
Chinook.
Is it the Chinook?
Yeah. So this is very similar to a Chinook.
Okay.
The Chinook is a collective pitch helicopter, so the pitch of the blades can change on one side of the rotation and the other, and that way it can sort of tilt the rotor disc and tilt the aircraft. It's a little hard for me to tell just from here whether that's the case for this one, but that's certainly a possibility as to how they're getting that authority.
Love to know what the elevation is on this. They have taken that thing up. Remember that 200 feet is the limit. 100 is kind of the hard deck. You dip below that, and it's not an official run.
Yeah, there's a couple possibilities. One, I mean, they could be doing some kind of a run.
Yeah.
The other thing is, if you're going to do, there's some kinds of testing you can only do in the air. Like you could test a lot of things on the ground, but eventually you have to put it in the air. And so if you were going to do flight testing and you weren't 100% sure if you would stay fully in control, then you would take it high. And then if you did something radical and it sort of dropped altitude, you would have time to recover it versus letting it hit the ground.
And just for the folks that are watching at home or around the world, part of the rules and regulations is once the event ends or the window's closed for the day, you're not able to take this to a local park and say, hey, let's give it a couple test runs.
No, it wouldn't be, like we said, over 55 pounds, it would not be legal to fly this. They theoretically could test fly it.
Yeah.
In the hotel parking lot or something.
Yeah.
No, not really, but theoretically it would be
They
legal
do have a
to do
run-up
that.
area here where
Yeah.
you can spin it up and lift it up and down,
Yeah.
but you can't, go major. So
I have in my life done some flight testing in an empty hotel parking lot.
What?
But nothing this big.
Are you confessing to a crime right now?
No.
Okay,
It was a much lighter aircraft, and it was all legal and safe. Don't worry.
That's how you roll.
We did get some looks though from the front desk.
This is Raging Cajun still up there as we take a look at the unofficial time. Looks like we've got about 10 T-minus 10 minutes for this flight window, which was pushed back to 10 o'clock. We were scheduled to go at 9, but Mother Nature had other plans. A little bit of rain came through the area here in Dayton, so we pushed back to 10. But now it is picture perfect as the raging cages come in. And will this be a picture perfect landing? Yeah, I'd say that's pretty darn good. So the next flight window is already in preparation, and the calendar, the timetable for that is very interesting. It's not just show up right before your window opens. This is Happy Hellfire out of Pensacola. This is one of the very unique. Was this on Stump Donna?
Yes, it was.
One of the Stump Donna designs?
Yeah, we did a segment yesterday, Stump Donna, where we showed him some of the most sort of interesting, and innovative, wacky designs and had him comment.
But
Donna, of course, being the...
broke it down, yeah. He made it look easy.
Yeah.
I thought that was like a one-man tent from Mount Everest, but that is not the case.
Looks kind of like a hang glider.
Yeah. So Happy Hellfire is coming up in the next flight window, which will kick off again at 12 o'clock Eastern time. And there is them. There they are yesterday. And we were talking about the gusty winds.
Yeah. In addition to the gusty winds, we talked about the difference between flying the aircraft fully loaded versus empty.
Right.
They have to complete an empty check flight and then a half-weight check flight, and you can almost see the aircraft struggling to get its nose down and get into that forward flight attitude. And one possibility is that's because they designed it around the weight, and it's just really having a hard time flying with the reduced weight.
So once that wing touched down, good thing is it's a pretty lightweight material, easily repairable. What kind of adjustments do they make, do you think, overnight?
Well, you could move the weight forward, depending on how you mount. If you've only got one place to mount the weights, you don't have that as an option. A lot of times on a remote-controlled aircraft, you will have the ability to move weight forward and aft to change the center of gravity. In this case, that may or may not be possible. You can see there that gray plate there is not a weight plate. That's the Titan plate, so that would have been a no-weight test run. And as we look closer at this, I don't see a lot of possibility for how they would change the weight. I don't know. Is it just strapped onto the strut? If that's the case, they could move it forward or back. But they have to complete that no-weight test flight first, and they just don't have a lot of options to change how the aircraft flies.
Now, that being said, they're not going to need to add a lot of weight on there to go to a 4-to-1 ratio, because I think that thing's got to weigh what?
Weighs
12,
very little.
15 pounds?
Yeah.
Got another craft up in the air, Hanamontan, doing some more testing as we come up on the final, well, under T-minus 10 minutes, we'll say, to be safe.
Yeah.
So Hanamontan's up, Raging Cajuns are up. A little flurry of activity before the witching hour, where we shut things down, and they are getting a little bit sideways, but a nice correction.
There you go. Brought it back in to control and setting it down.
You
Of
go.
course, I can't see. Yeah, no, they set it down right next to the landing area. I wasn't sure if they set it down in the field.
Extra points if you put it right on the landing pad?
Yeah. Well, extra points if it's right on the landing pad, but if it's touches down safely and is undamaged. You know, they say with full-scale aircraft, any landing you can walk away from. With remote-controlled aircraft, we like to say any landing you can take off from again, and any landing you don't have to walk to go retrieve is a good one.
This is the action in Lane 1, the team from Foster City, California, Hanamontan. We saw them yesterday at the close of day number 4. Got a little bit of precipitation that came through, so they shut it down a little early, and they're back. Looks like they made some modifications. That was a weighted test. I don't know how much weight it was. It looks like the Raging Cages are going to spin back up again. Why not?
Yeah, they got time. Get it up. You know, as you move to these novel designs, as I said, the question is not sometimes will it fly? And obviously we're seeing it fly, but will it fly in control? You know, if you start adding weight, is it going to stay in control? And, you know, if you build an established design that you know will fly, then you may have limitations on just how much weight you can carry. So we see a lot of these more innovative designs, and we see them spending time just solving the problem of getting it to be safe and stable enough to begin to put weight on. And all of that work pays dividends, whether you end up getting a run or not.
So the team from Lafayette, Louisiana, going up for another test, making the most of this 90-minute flight window here on day number 5 of the DARPA Lift Challenge. Another one next flight window coming up, and it will be top of the hour, high noon here in Dayton, as this team has been given a bit of an extension, so they'll go to 11:40 Eastern time, so they still have roughly 10 minutes to go.
Seeing him set down here. I'm not sure what the red ribbon is dangling off. Maybe an orientation marker for the pilot. And when you have an aircraft like this where it's not obvious where the front is, the pilot obviously needs to know which way the front is. If it's facing a direction and you tell it to go forward, it'll go in the direction it's facing. But if you don't know what direction it's facing, it may not go the direction you intend it to go. I would guess that red ribbon is an orientation marker for the pilot. And you might say, well, why don't you just, paint one of it green? But again, because these pilots are flying line of sight, that means they have to maintain view of the aircraft with their unaided eye. And when it's 1 mile downrange, it gets mighty, mighty small in the sky. Seeing that ribbon fluttering may be something that would be a little bit more visible than just painting a color.
It looks like they've got a little bit of weight, Joshua, on the left-hand side there.
Is that the Titan module,
Titan's
though?
on the right-hand side.
I do see. I see. You're right.
Yeah,
You're right.
plate.
Titan on the... Yeah. Well, but Todd, is it the left or the right? We can't see the ribbon.
The left, as you look at it on the screen. I'll say that. Now you're just testing me. First place team, Aviadrome, will be up in the next flight window. That'll be at 12 o'clock Eastern time. And we'll see what they decide to do. Do they come out and drop the proverbial gauntlet on the rest of the field? Already with a 3.84 ratio and the lead, so they are so close to that 4-1. Extreme Aerial Concepts, we saw them already earlier. H squared as well, 296, and then MacGyver at 251. That's your top four right now. Those are the teams that are in the money, but you've got a lot of great minds that are chasing, and the chasers still with an opportunity with really 3 full days of competition left to go, Saturday and Sunday plus today.
Yeah, and I know that the DARPA organizers put a lot of thought into what the exact targets should be for this challenge to try to produce a useful, meaningful result. And I'm sure there was a lot of debate over what the ratio for payload to weight would be, 4.0 or some other number. And as I see participants in the challenge getting so close to the 4.0 number, they're all in the 3.0 range. One of them just barely not quite getting to 4.0. I got to say, if it was me, I would feel like I had picked the right number.
Yeah.
I want it to be just out of reach. I don't want you to just run up and snatch the ring and come back and say, see, I did it. And I also don't want it to be so far away that you go, I'm never going to get there. Yeah, I feel like
Looks like the Raging Cajuns are going to call it a session as the flight window comes close to closing. There were just 2 teams out on the flight line that were active. And this has the makings of, let's bring it in the shade and get ready to transport. So again, I want to remind you, coming up in less than 30 minutes at the 12 o'clock window, you'll see the team that's currently in first place here at the DARPA Lift Challenge. They will be back out on the flight line. We'll see what they do. Is today the day that someone goes over and conquers the 4-1 ratio, or they wait? Only team that is still on the flight line and lane open is Hannah Monton out of Foster City, California. All right, so what are your takeaways from this first flight window on day 5?
Well, we saw a change of place. We saw somebody move up the leaderboard, and it's always nice when there's a change in the leaderboard. We see a lot of teams gathering data and continuing to refine their approach.
You know, someone asked me one time, and I cover snowboarding as one of my other side jobs, and they say, what did you think of the event? And I always say, I saw progress, so it was a good event.
Yeah,
anytime
absolutely.
you see progress, anytime you see someone do something you haven't seen before, someone pushing the limits on something, it's a good day, it's a good competition. And I think we can say safely, flight window on day 5 to kick things off, despite being pushed back 1 hour because of the rain, was a big success. We saw teams, again, pushing the limit of what they can do, and I think the future, awfully bright.
Yeah, very much.
So we'll remind you one last time, 12 o'clock. If you can just stay with us, you'll be seeing some great stuff, including the current leader at the DARPA Lift Challenge. That comes up at high noon here from Dayton, from the beautiful Museum of the United States Air Force here in the DARPA Lift Challenge in Dayton, Ohio. Rain clouds have cleared away. Flight Fest is underway, as is the DARPA Lift Challenge, and it looks like we are just about to close out this flight window. What do you think? The Cajuns look like they're done?
It's hard to say what they would do. They still have 5 more minutes of flight time available to them. If we speculate that the test flights we've seen them do relate to, they're trying to tune the craft, they're trying to sort of establish basic control, then it might be valuable for them. If they feel like they've gotten somewhere with it, it might be valuable to add a little bit of weight and try to get it up in the air.
I know every drone's different, JB, but what is the spin-up time? I mean, from the time you get it out to the flight line, let's say fuel and go, or is there a longer checklist than that?
Yeah, it depends a lot on the type of drone, the type of fuel, power source, battery or fuel, and then obviously on the sort of environment. For these larger aircraft, they're more like full-scale aircraft where you will have, because there's so much danger potentially with those giant spinning rotors, you would treat them much more seriously, and you'd have a very detailed startup procedure, and it might take 15 minutes, 20 minutes. With the smaller aircraft, like a little racing drone like I might fly, I know when I leave the house that it's good to go. I'm going to get there, I'm going to slap a battery on it, I'm going to check my goggles to make sure I have good video and good control, and then I'm going to start flying, and you can get in the air within 5 minutes or so. Yeah.
So looks like there is some serious energy right now, possibly to try to get back out on the flight line for the Raging Cajuns and get this thing up. They've got about 4.5 minutes, I'm being told.
Yeah, and
so
that time, I mean, they were granted 10 extra minutes because for some reason it was determined that they were entitled to it, but that 10 minutes is, they have 10 minutes and they need to get up. And again, the drone does need to be on the ground before the window closes.
So Ann Bush, the technical advisor for DARPA here, she is the one that has the juice, has the power to shut down this flight window. You spoke with her earlier today?
I spoke with her earlier today. We did a little interview, and she showed me the command center with all the screens where they are just monitoring everything that's going on here. There is a huge focus on safety, of course, knowing where all the drones are, but also a huge focus on data gathering and fairness, and that was something I hadn't thought of before I spoke with her. DARPA is going to award $6.5 million in prizes, and we want to make sure that there's no question that the team that earned it is the team that actually earned it. And so they're recording every bit of data in their Titan system and tracking everything that's going on.
We think we've seen a lot of runs. She's seen every second of every run,
second of every
Monday.
run, literally. Every
she
second.
has nightmares of drones when she goes to sleep. Like, no, the drones are coming for me.
Yeah. We say a team has been entitled to 10 extra minutes, 5 extra minutes. She's the one who's making those calls. And so I've heard stories that teams will say, oh, hey, something happened. Can I have 10 extra minutes? And she'll be like, denied or allowed. Yeah, good reasons.
She has her reasons. It's just not just she's in a bad mood.
Well, it has to be kept fair.
Yeah,
it has to be kept fair, but she's the sort of arbiter.
There you go.
Yeah. So I guess if there's anybody you want to anybody you want to make sure you bring Starbucks to.
All right, so the Raging Cajuns are going to spin this thing up with the limited time that they have. Looks like there's a little bit of weight on the left side of your screen.
We got a shake.
That's never a good sign.
Not good. That shake speaks to one of the rotors being imbalanced, or anytime you have rotating mass, if there's any imbalance at all, you'll get a shake. And it is never encouraging when you see a drone taken off with a shake like that. This one doesn't seem too bad. Now they're in the air. It seems to have sort of settled itself in. And sometimes it's like, when your wheel on your car is unbalanced, you go 55 miles an hour, you get a shake, but you go 65, it settles out. So, like, they may have sped up that rotor. Or maybe that problem came back and bit them.
It's one of the situations where you got an extra 10 minutes. Not always sure you'd be grateful for what you got, because that could have gone bad quickly.
Yeah, but I mean, you have to try, right? I mean, if you want to do the full run, you're going to have to do the halfway run first, and eventually you get to a point where you've tested and you've tested and you've tested, and you just have to see what's going to happen when you
Okay.
do the real thing. You know, there's no excuse for actual testing and engineering.
All right, well, this is Flight Fest going on the other side here at the museum. And look at this. This is what we were talking about earlier. This is like the demolition derby
Yeah.
for RC planes.
Yep, so these are small radio-controlled planes, and they put as many as 70 of them, in my experience, up in the air at the same time, and they intentionally try to crash into each other, and the last plane in the air is the winner. And it is hard.
I was going to say, can you hit another plane and still continue to fly?
Yes. So
Okay.
these planes are shockingly durable. They're often made of foam, and so we'll see planes get half their tail knocked off, half their wing
And
knocked
still
off,
go.
and stay in the air. Absolutely. And it is surprisingly difficult, or maybe not surprisingly, when you're staring at that plane with your unaided eye. Number one, just to keep track of which
Yes.
plane is yours, and then number
Yes.
two, you have to line up on another plane and hit it, and,
Yeah.
and gauging that distance is very difficult. If
Here's
we're-
my strategy, JB.
Yeah.
I'm putting my plane in the air, and I'm going as high as possible. I'm just
Oh,
circling and watching the
wow.
chaos below.
Well, two things about that. Number one, that's not in the spirit. And number two, somebody's going to see you up there and go,
I'll make some passes.
screw that guy in particular.
I'll make some passes. I'll take a dip down the middle and head right back up.
Yeah. Nah, these guys just love the
Look at this.
carnage. And the beauty is that, if you think about radio-controlled planes from the 60s, 70s,
Right.
and 80s, they were made of balsa wood. They were very expensive and very time-consuming, and you would never crash one on purpose.
Yeah.
But these little foam planes, they're very inexpensive. They don't cost nothing, but it really makes taking risks like this
Sure.
possible.
Look at the crowd down there. I mean, that's not just
Yeah.
the people lining up to get Joshua Bardwell's signature. They're here for Flight Fest as well
Yeah.
as the DARPA Lift Challenge.
That's true. One of the largest RC flight festivals in the United States. Happens every year. And I believe they moved it. It's normally held at another location. They moved it here to coincide with the DARPA Lift Challenge so that people could come attend the DARPA Lift Challenge and visit the Museum of the U.S. Air
I'm
Force.
so glad they didn't ask me to do play-by-play on this event because
Oh.
I have no idea.
Yeah.
I kind of want to see a midair. Oh, there's a plane
There's
coming
one
down.
plane coming
He's
down.
coming down.
That's what I was going to say. If we're lucky, we'll
That's
get
a
to see some
wound- I was gonna
collision.
say, that's a wounded bird.
He's down. He's down. They do have an announcer over there. Maybe
Come
you
on.
should meet. Yeah, no,
That
you
guy's a
should meet him.
legend. He or she
Yeah.
is a legend.
Yeah.
Keeping track of who's who. Look at that. That is. First
Yes.
time I saw that from a distance, I thought, oh, what are those seagulls over there swarming?
Yep.
So this is Flight Fest 2026 from Dayton, Ohio. This is intentional. They have put their planes out there. They have certainly put them in harm's way, as it'll be last plane standing. And they do this 2 or 3 times a day.
You can see one of the planes with a streamer on
Uh-huh.
the end. So there's a form of RC flight dogfighting where they
Yeah.
try and cut each other's streamer instead
It's
of
like
crashing into
kite
each other.
runners.
Makes it a little more
Yeah.
survivable.
So the field has been thinned out quite a bit from when it originally started about 4 or 5 minutes ago. And you can see the carnage on
So
the
you're
ground.
already able to call it. You're
Oh,
a
yeah.
natural,
I'm
Todd. You're a
I'm all
natural.
about this. This is pretty exciting to watch. Anyways, I digress. We are at the National Museum of the United States Air Force at the DARPA Lift Challenge in Dayton, Ohio. Todd Harris, Joshua Bardwell, and Elena Buenrostro. Been a great day so far on day 5. Want to remind you, coming up at noon, we've got the next flight window. But before that, let's take you back to some of the action from yesterday. We welcome you to Dayton, Ohio on a beautiful day here as we get ready to make history in the world of aviation. We do have liftoff, so here we go.
I can't emphasize enough how friendly everyone is here at this competition.
Initially, we had really crazy ideas, but then we realized, that it's not so easy to do.
We're, believe it or not, flying better than ever.
Oh, he's going to put it right in the center. Now he's just showing off. Oh!
You gotta stop giggling.
What just happened out there?
We're testing the limits, so we found it.
Inflatable structures can become a drone that you can carry in a backpack that can carry you.
Seems like we had a little bit of an electrical issue on takeoff.
We'll rebuild that, and then we will try it again.
Avadrone, put it up there at 3.84 on the ratio.
Teamwork makes the dream work, and we're doing well here.
It's been an awesome couple of days, and we can't wait to keep on flying here.
used to be a very unique subset, highly trained group of people at select large companies that designed and built airplanes. Now it is open to the masses. And that is where the excitement comes in. That's where the power of outside of the box thinking has the ability to really change what we know about aviation.
It gives university students and young engineers the rare opportunity to get their hands dirty, solving a very real national security problem today, rather than waiting a decade into their careers to make an impact.
These people, they're literally out in the field right now, turning wrenches, making tweaks to their aircraft, and proving that it takes a diversity of ideas to make that breakthrough, to find that golden nugget that will take us, humanity, to the next level of innovation, the next level of capability.
If we want drones to deliver serious supplies like food, medical kits, or even repair parts, we need to break away from traditional designs and investigate what will push us to a new paradigm of heavy lift.
This breakthrough matters to everyone because it will enable faster and more efficient military logistics, transform commercial and supply chains, and allow for quicker disaster relief to hard-to-reach locations.
We've only got 4 of us here, so we've all got to do a few jobs. We are Defentex, an Australian defence research company. We've headed over to the US to compete in this challenge. So right now you're looking at our loaded check flight. So we got 55 pounds on there. Our drone weighed in at 15 pounds. So we really went for a lightweight concept with this drone. So currently you're seeing approximately a 3.5 to 1 ratio on the flight right now. We had to rebuild this drone yesterday and last night, as we unfortunately had a couple crashes, but we had enough parts to thankfully build another one. And after a few changes, we're really hoping to get a competition run of 110 pounds in today, but we'll see how it goes. So we've been working on this drone pretty much since the challenge was announced. And yeah, we've been working on it in addition to other projects at work since the competition was pretty much announced and we got the go ahead to have the funding and the resources to put a drone together for it. We went for the concept of we're aiming to do the minimum payload, and we attempted to minimize our drone mass. It's been one of the most enjoyable parts of the competition so far, is meeting all the incredible engineers and concepts that they brought to this competition. So that's 55 pounds on there. It's our loaded check flight. But in addition to the regular check flight of just up and back, we're also doing some tuning of the controller at the moment.
So we don't see the green mark at the top right saying that they're going for a run, but there you go.
And a big set down.
Big, hard set down. Those motors were pulling hard to lift. Perhaps it was overweight. It was maybe one of the motors got hot.
The first run was good. We were just checking it. It wasn't an official run, but we were trying to work our way up to the full 110 pounds, because our strategy is a bit weird where we have to lift 110 pounds to score. Like, our ratio is already very high, but yeah, everything's a bit hotter than expected, and also we haven't had much time to test stuff, so we're kind of learning on the fly. The second flight, I don't know, lost power. I'm not sure why. Yeah, it still had control and stuff, but I pretty much went to full throttle and it was just sinking. So we'll have to investigate what it was and build another one.
Imagine carrying 4 times your own body weight. Crazy, right? We want a drone doing exactly that. That's the challenge we here at DARPA are throwing at inventors across America. And if they succeed, we could see a whole new generation of propulsion systems. Today's drones are limited by how much thrust they can generate for their weight. Some drones can carry a lot of weight, but they are very heavy and cumbersome themselves. But what if the teams competing in the DARPA Lift Challenge create ultra-efficient motors, revolutionary propellers, or entirely new and previously unimaginable ways to generate thrust. Suddenly, a compact drone could carry equipment that today requires something much larger and way heavier. More efficient propulsion could influence cargo, emergency response, and future air transportation systems. More lift, less weight, better performance. Sometimes when engineers chase an impossible-sounding challenge, they end up reinventing the future.
I figured for something like this, actually, like a very small team was actually the best thing because you can move very fast. So I actually built the first drone before I was even accepted as a team in this. I like just assumed that, you know, if I tried my best, I'd probably be accepted. And so I built the first one, you know, like less than a month after the challenge was announced. And then I've been test flying since then. So this is actually the fourth drone. Basically that I've built. So, but in terms of, you know, I went for very simple. Like I've built a lot of drones. I know the stuff that works and the stuff that doesn't work typically, and so I wanted to keep it, you know, as simple as possible and like realistic. And so I did a lot of simulation work on what is, you know, the least amount of structure I can use to still lift reasonable. This thing is actually like rated for up to like 250 pounds. So hopefully I don't eat my words out there, you know, with less than that, but it is rated for a decent amount in this iteration of the design. And there's a lot of small things with the design to optimize wiring and how the motors communicate. We were able to get away with not having certain components because of how I did things. But the main innovation with this is the battery. It's a custom battery that I made. That allowed me to maximize my energy density for, you know, the weight that I had left over in the budget, basically. I'm definitely willing to crash it, so, you know, we'll see. Oh, I just bought like a $3,000, you know, pretty junky Sprinter van, like an 05 Sprinter that's pretty much fallen apart, and that's what I use to transport everything for flight testing, and you know, did the bare minimum to fix it up to drive, and that's what I got here. Drove all the way out here, had to go 50 miles an hour the whole time because it basically can't do more than that. So yeah, so that's what I'm working out of, you know, self-funding. I spent all the money on the drone, I didn't spend it on the transportation, you know.
Obviously, the hard deck is not in play. Seems like they're bringing it down.
Yeah,
Ooh, a little wobble there.
Pretty quick.
Oh, they lost the weight, and it jumped back up in the air as that weight freed itself. The pilot maintained control expertly.
I don't know.
No, that wasn't on purpose. No, sorry, that was not on purpose.
But you never know, like when you start going, how the position control stuff is going to go. So, yeah, lost too much altitude in one of the, you know, far runs, and it kind of just barely breached over there. So had to bring it back, and then wanted to do some more tuning, and you guys saw how that went. You know, it was coming down a little too fast, and even though, you know, I was 100% throttle, I still couldn't keep it from, you know, hitting the ground. But it didn't hit the ground that hard because, you know, all it did is really break the straps, and then as soon as the weight is gone, that, you know, that thing has a lot of power, so just shot straight up. So, but we're all good. Everyone's safe. Everyone's all right. I think I'm gonna give it another try. I have a second drone actually, and I have another battery. We'll try to crash it again or do it successfully.
Being here at this museum is amazing. It is filled with design innovation from brilliant minds who have thought outside of the box. DARPA has been a part of many of these designs that are on the floor, on the ceiling. It's really exciting to know that the top 3 performers out of this challenge are going to be here. They're going to be displayed. They're a breakthrough. We are making history at this challenge. For me, this is just a stamp in time, this one challenge. What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge. What does that future look like? For me, that is more exciting than this one point in time, this one challenge, and the week of flying that we are doing. The future is being created, and it's going to be celebrated in these hangars for decades to come.
Here at the DARPA Lift Challenge, safety is paramount, and that is why we have partnered with the Federal Aviation Administration. From the outset, we designed this competition to uphold the highest standards of aviation safety while pushing the boundaries of innovation. Every operation is conducted within a structured flight environment that enforces clear boundaries, layered safety zones, and strict response protocols. All remote pilots participating in the challenge are certified under Part 107, meaning they have demonstrated a comprehensive understanding of airspace rules, emergency procedures, and safe unmanned flight operations. But beyond certification, these pilots bring something even more critical. They and their teams have intimate, hands-on knowledge of the aircraft they are flying. They have designed, built, tested, and refined these systems, giving them a deep understanding of performance limits, failure modes, and recovery actions. This combination of regulatory compliance and engineering ownership ensures that every flight is conducted with discipline, accountability, and precision. At DARPA, advancing technology never comes at the expense of safety. It is the foundation that enables innovation to move forward responsibly and ultimately transition into real-world use.
We crashed and burned. We had nothing left to lose. We were like at the absolute bottom. We were almost in tears.
Believe it or not, we're back, and we're flying better than ever. We had this extremely beautiful craft that is highly engineered. It's like a race car. Everything component's been dialed into the max. We had custom everything, and we had a component fail on one of those power boards that immediately cut two of the motors, and that's when you saw the aircraft do that flop. Dropped 125 feet from the ground and landed on its top. The root cause of the power failure, we suspect it might have been water. Just the morning dew. You get water in the wrong spot, and that's it.
The theory is that this capacitor sustained damage, failed, which then created the electrical conditions to cause a larger catastrophic failure here.
We have a bucket of all the components we've ripped off. You can see how the carbon fiber is all just destroyed and it crackled and sprinkled. But thankfully, like saving grace, the pods grenaded, but the Empresses were inside of these pods, buried inside, and because they grenaded and took all the force, yes, it was bad that they grenaded, but the batteries are fine. It didn't explode. We still have an aircraft. We came back here with our tails between our legs being like, oh man, this looks so bad, because it had fallen, crashed, caught on fire, and then Crichton, our CEO, comes to me and says, can we fix this? And I thought, I was like, okay. As one of those things, like maybe we could bolt some 2x4s on. You're thinking, you're grasping at anything, and then it turned out that was the best thing ever.
This is our homage to the Wright brothers. The airplane was made out of spruce and balsa. Yeah. Ours are 2x4s from Home Depot.
Transformed from an F-35 next generation to like an A-10 tanker, like really just rock solid. So it's not as sophisticated, man, but it flies beautifully. I mean, Greg here can attest, like it is a dream to watch.
Like once it goes into that final flight configuration of spin, which is what it's designed to do, it just locks in and it becomes very stable. And that's how it's meant to fly.
It was designed to spin, and it does so beautifully. It was spinning fast enough to generate lift that you had to back off on the throttle.
We were just going up like a rocket, had to drop the throttle, and that just turns it in from a inefficient craft taking off like a quadcopter to a really efficient high lift aircraft.
It's forced us to simplify so many parts of our craft that the process of doing that and thinking that through has resulted in a mode of flight and a design that we think is, possibly in some ways better than what we had.
We spent so much time with the math, with the theories, with the formulas, trying to dial in that 4-to-1 at the 30 minutes, the 4 nautical miles. And in doing that, everything gets more complicated and more complicated and more complicated because we're chasing those decimal points. All it takes is one small thing to go wrong and the whole thing just falls apart. So simple, 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 robust, robust, robust.
Plan is now, by Sunday, we're dialing things in because there's a lot of things we've still got to change and improve. We've got a lot, we can turn those 2x4s into Swiss cheese and reduce our weight. There's a lot we can do. And the plan is by Sunday we'll be at pretty much as good as we can get with this craft. The camaraderie has been amazing. We've probably done 2 years of R&D in 8 months. It's just been insane. Coming together day after day, how do we do this? And, we've got that respectful disagreement, which is what you need for a team operating at this level. People are contributing ideas, critiquing ideas, providing feedback, and at the end of the day, we're like, this is collectively the best way forward, and we're all on board every time that happens.
It's really compelling, just seeing everybody rolling with their own little punches, and you try and overcome it and you find the workarounds and you make it work, and you sort of see how that plays out for everybody in their own little story.
And day 5 continues of the DARPA Lift Challenge here at the National Museum of the United States Air Force in Dayton, Ohio. Todd Harris alongside Joshua Bardwell and Elena Buenrostro. Glad to have you with us for our second flight window of the day, scheduled originally for 9 o'clock start today. Rain pushed that back to 10. We just finished one flight window, wrapping up around 11:40 Eastern time, and now we're right back at it here in the second flight window. All right, JB, what did we learn from the first flight window, and what do you expect to see in the next?
Well, we learned that there's an advantage to improving your standing, even if it doesn't move you up the leaderboard. Makes you just that little bit harder to dethrone. And what I'm looking forward to next is I am going to start hoping, because I've said the 4-to-0 payload to weight ratio so many times, I'm going to start hoping that one of these long shot teams with the 9-to-1, the 16-to-1 payload to weight ratio figures out how to actually get a run in and just blows the leaderboard out the top.
In case you're wondering what an official run would be, that is 4 nautical miles with a 4-to-1 payload to weight ratio. Come back to the landing area, unload the weight, then do 1 nautical mile without the weight, staying above 100 feet, staying below 200 feet, and you're in the money.
That's right, in the money.
And this isn't just chump change money.
No, $2.5 million for first prize, $1.5 million for second prize, and $1 million for third prize based on the payload to weight ratio. Again, though, it's important to note that you only get the full prize if you hit that 4-to-1 payload to weight ratio. A 2-to-1 payload to weight ratio, though, does get you half prize.
And then there's also the subjective. There's 3 other categories that can earn you upwards of $500,000.
That's right, $500,000 for a subjective category. Just kind of like a best in show. The idea there is that there may be noteworthy entrants. They did something interesting. They created a good result, but they didn't necessarily hit the metric.
Do they have the design? Are they the most promising? And if they can check all those boxes, they could possibly be walking away with $500,000 in prizes, even if they don't get into the big money category. So we've got a 90-minute flight window that is opening up here momentarily. We'll wait for Ann Bush to give us the absolute final word. There's Happy Hellfire, one of the designs that we kind of circled as very interesting and unique. We saw them fly. We saw them catch a gust of wind. So if it's not too windy, which today is not too bad, I won't get too deep into the weather, but it looks pretty good. It's a little warmer than I think it's been the last couple of days, so a little more humid.
We had some rain this morning, so it's a little more humid. I don't think that'll affect the results very much. Happy Hellfire, basically a hang glider with a quadcopter strapped to the back. The idea is that they'll take off vertically with that quadcopter component, and then they'll pivot to horizontal and fly, taking advantage of the increased efficiency of a wing. Quadcopter is very good at going up and down, but not very energy efficient.
How about this? When you get a hometown team competing in the DARPA Lift Challenge here in beautiful Dayton, APRAD, in lane number 3 in the entrepreneur category, a bunch of YouTubers and engineers with a backwards way of designing revolutionary new DARPA aircraft. They say, we reserve previous expectations of heavy lift to lift heavy. Genius.
Yeah. Well, you got to think outside the box.
These are your people. You got $400,000 YouTube followers. And the paint job? Come on.
I love the cat. I love the cat. These are my people.
I don't know if I can legally say Hello Kitty, but yeah.
So we've got a gigantic rotor here. It's not clear to me how it's driven. I don't see the kind of sort of shaft and gearing and motor that would be consistent with a motor-driven design. And actually, now I am seeing there are propellers on the end of the rotor, so this is going to be what they call a tip-driven design.
Okay.
The idea being that those propellers are going to pull the main rotor wing around. And you might say, well, why don't we just use those propellers to generate lift? And the answer is that the larger an airfoil is in general, the more efficient it is, and this is all about efficiency.
All kidding aside, they say that they are a group of engineering YouTubers. You could be influencing APRAD.
It's possible. I mean,
at least on the
we
paint
could,
job.
I would go by and see them and see if their faces light up, and they say, "Hey, it's Joshua Bardwell." You never know. That's always nice when that happens.
So this is the second flight window on day number 5. Of course, we have tomorrow, day 6, and then we'll wrap things up on day 7, all trying to reach the 4-to-1 flight weight ratio. And this is hovering owls, and we've got liftoff, first of this second flight window. Wasted no time.
Yeah, 4 minutes into the flight window, we've seen a lot of teams come up, and obviously, there's a lot of things you got to do before you get in the air, safety checks and so on. So we see a lot of teams come up, and they don't get in the air for 10, 15, 20 minutes, maybe. They're 4 minutes into the window, they're already in the air, and they're already checking things out. And that's good because they have the full 90-minute window to make attempts, and they can make multiple attempts.
So hovering owls out of Boca Raton, Florida Atlantic University. I'll give you a quick guess. What do you think their mascot is, Florida Atlantic University?
I have no idea.
Got to go with the owls. Not hovering owls, but the owls.
The owls, okay.
They're competing in DARPA's Lift Challenge, designing and testing a heavy lift autonomous tilt rotor for next generation aerial logistics.
Here's what's interesting to me about this one. You can see that the main body of the craft looks like a wing. It looks like an airfoil, and that suggests they're trying to take advantage of that efficiency gain. And you can also see that the motors lifted up like a traditional quadcopter, but I'm curious how they will transition to forward flight. If the quadcopter just pitches forward, the wing will be facing the wrong way.
And this is lane 12. This is Phoenix Drone out of the aforementioned Phoenix, Arizona. Veteran-owned company of Honeywell scientists and engineers with several decades of cumulative UAS, RC, and manufacturing experience. They say we are Honeywell startup spin-off sponsored by Honeywell Aerospace Technologies, M4 Engineering, and Invention USA. So they've got some backing by some serious players. The team out of Phoenix, Arizona. This is Phoenix Drone.
Yeah, it's interesting to see. We've got all kinds of people here from small, literally mom and pop, all the way up to backed by larger money and more sort of traditional engineering. And everybody's just bringing their best ideas and seeing what they can do.
This looks pretty burly. I mean, this is pretty stout.
Yeah, well, we don't know how heavy that is. We know they've designed it to be as light as it can be while still being as strong as it can be, but we certainly have seen some very spindly structures that didn't really survive a crash. We've got these 2 large main rotors, and we definitely need a strong frame to carry them.
Guess how heavy it is. I can tell you right now.
Go ahead.
What do you think? What's your guess?
Well, I'm looking at the plate. They've got a single plate on the bottom. The 55-pound limit. That's what. So there's a 55-pound limit. It took me a minute. I got there.
45.9. So it's well under the 55. So you're saying there's a chance.
Yeah. And of course that weight matters because the key metric here is the payload to weight ratio, the weight of the aircraft and its fuel or batteries relative to the weight of the payload that it can lift. So the lighter the aircraft, the higher the payload to weight ratio, although also makes it harder to lift it in some cases.
It's kind of a cool design. I mean, I don't know if they use that and how they cut that, or if it's just carbon struts and what it was all done. I mean, we've had everything from 3D printing to balsa to, I literally think there might be some duct tape out on the flight line.
Oh, there's a lot of duct tape on the flight line, I assure you. Probably not structural duct tape, but yeah.
So this is Phoenix Drone, went up, took a peek, came back down. Again, another kind of a Chinook-looking design.
Chinook, yeah, that dual-bladed helicopter used primarily by the Army, and you get a lot of lift off those big propellers. So the idea, I guess, is if you want to lift more, you just add another propeller.
Yeah.
Yeah,
well,
so you can see them trying to land, and they're not accepting touching down in the grass. They're trying to touch down directly on the landing pad.
There you go.
If they did touch it on the grass, it wouldn't be the end of the world, but they're holding themselves to a standard.
Try again. Lane 15 just moments ago, the team from Pasadena, California. This is Falcon, and they are backed by Hobby Wing out of Pasadena, California. And
that is never good to see. That's never good to see.
You talk about spindly. That thing,
Yeah.
I mean, it just kind of, I don't say disintegrated, but it took a beating.
Yeah, yeah. So that can happen if you got all these propellers and all these motors, and they're all pulling the craft in different directions. And the little computer on the aircraft, the flight controller, is in charge of managing all that. And there's various kinds of misconfigurations can happen where the flight controller thinks that it's moving left, but it's actually moving right, and then the whole thing goes wrong. And when you see a flip like that, it could be something as simple as, like, presumably they configured it right and they test hovered it. It could be something as simple as they put the wrong prop on the wrong motor, and it'll flip like that.
So I'll ask you to speculate here and look into your crystal ball. That is fixable, but maybe not in the next 90 minutes.
That's tough. I mean, those struts, like, you would want to replace those struts. You can see the motors are broken off the struts. The propellers are broken. The propellers, of course, are easy to replace. They're mostly
Hey, don't be a glass half empty. This is a glass half full situation.
Where I was going is, if they are going to fix it, they're going to need to basically replace the struts. You're not going to repair a strut. Now, the nice thing about this design is you don't have a lot of custom parts. It's basically just tubular struts with some kind of coupler, and so it's relatively easy to have spares.
But more than likely, they came with spare.
Oh, you would assume they came with spares. For example, I mean, for all I know, they have a whole second drone ready to go.
True. All right, so as they assess the damage there, we take you over to Happy Hellfire. This is the team out of Pensacola, Florida, in the small business category. Small team building next generation of heavy lift autonomous drones. And our Elena Buenrostro spoke with them and has this report. Elena.
I'm here at a prep tent, and yes, I did get to speak with Happy Hellfire. It is a team with 1 professor and 4 students, and their design is really inspired by a paraglider in between a quadcopter. So it's a really interesting design. They told me that their challenge has been the wind, which I've been hearing from a lot of the teams that are taking this approach with a paraglider in the middle of their quadcopter. And then I think another thing is they've attempted to go up, they've gone up twice, and today in this run they're going to be going up with 55 pounds. So we will see how they do. I'm excited to see the progress and the turnout.
All right, thank you very much, Elena. And she brings a good point in right on cue as the wind starts gusting just a little bit. This was the other day, and to Elena's point, the wind kind of played havoc on this light frame.
Yeah, although if they're being allowed to go up with 55 pounds, that's actually going to help them. The heavier craft is going to be less affected by the wind, and so we may actually see them be more successful at the higher weight.
Yeah, you see what a gust can do, though, when it catches just
a big sail.
This was the moment right here where it just got away from them just a little bit.
And you see you've got those 4 quadcopter motors, and they have to sort of torque that whole thing around. And you can imagine that whole sail surface catching the wind and how much force you would need to keep that upright.
Let's go over to lane 8 as we continue to make the rounds here on the second flight window of day 5.
This is notable. This is the first of the tip-driven rotors. You can see those propellers on the end of the rotor that'll make it spin. The first of them that I've seen that has 3 rotors instead of 2. A 3-rotor configuration is going to give you a little bit more thrust. The more blades you have, the more thrust you get, but is a little harder to balance.
This is Casey Space Pirates. That thing is massive.
Oh yeah, larger wing, more efficiency. But of course, structurally, you think about elephant versus an ant, right? You know, you get larger wings, you get more efficiency, but it also becomes harder to support itself under its own weight. And then, of course, you start swinging that thing around in a circle, and it gets even harder.
Casey Space Pirates out of Kansas City, Missouri, in the small business category. Technical competition team built and best known for their NASA Space Elevator games and NASA Watts on the Moon. So they've been around the game for a while, and now they come to the DARPA Lift Challenge looking to cash in big. If they can go 4-to-1 on payload to weight ratio and put up the biggest weight, they will walk away with the biggest check, which is, drum roll please, $2.5 million.
That's right. That certainly is life-changing or business-changing money.
Oh, my goodness. That's a serious amount of cash.
Oh, yeah.
So they're going through the final preparations, and it looks like, and I'm not going to even guess how much weight they have on there, the gray disc at the bottom, that is the Titan or the data gathering and
Yeah, that's what's used to track the aircraft's altitude and position, speed, and so forth. They all have to carry that.
Yep.
Number one, so that they can track the data and know who actually won. And number two, so that everybody stays safe and in their prescribed flight area.
Give you a look at what the Titan board looks like, and this is really cool because you can look at each team, gives you the distance, the ratio, the altimeter, and then you can flip it and get even more. And that tells them, and I thought this was interesting, Donna was telling us about it, in case there's an accident, crash, a fire, they know what material they're dealing with, the fire crew.
Yeah, what exact fuel, and so the fire crew will have different procedures depending on if it's a liquid fuel or battery, and this tells them the information that they need. We can see that there is the red lines, the green and the yellow lines around the flight zone, and the pilot is expected to stay inside those lines. Of course, they have to do that manually. Well, I guess they don't have to do it manually, but most of them are choosing to do it manually just to make sure they can get it done right. And this is the information that DARPA is recording for the whole competition to make sure that everything is being done as it should be done.
See that green dot? That is the drone that's getting ready to take off and head down the lane. Again, they have to go down, turn, come back. Total 4 nautical miles with payload. And then they have to drop the payload off and then put up 1 more nautical mile, staying above 100 feet and staying below 200 feet. So we take you back to KC Space Pirates as they are going through their final preparations. There you see the pilot's control.
Dropping his controller, he's doing some checks. Getting ready to spin this thing up, presumably.
So as the Pirates get ready to go up, we take you back to Team 67, appropriately labeled. APRAD out of Dayton, Ohio, local team.
Now I see we've got some plates sitting on the deck here, and it doesn't look like those plates are secured. My guess would be that they're doing some kind of a spin-up test, but they don't want the aircraft to actually take off, and so they've added some weight. A very interesting design. It does look like we have a tail, like a vertical stabilizer on the tail, and a huge main rotor. We don't have a tail rotor, so helicopters, of course, have a tail rotor to counteract the torque from the main rotor, but when you have a tip-driven rotor, that counter torque is greatly reduced. The rotor is basically just being pulled along by those propellers on its edge, rather than sort of twisted from a central shaft.
That thing is absolutely massive.
It is.
Oh, we got Hovering Owls, team from Florida Atlantic.
And this is definitely what you want to see. Just in the air, smooth, stable, doing presumably exactly what it's being told to do. When you start to see wobble or dips or sudden movements, usually that indicates something has happened that wasn't intended by the pilot.
So we're being told this is a half-weight check flight for the Hovering Owls out of Boca Raton, Florida.
And it's kind of inspiring to me to see. I mean, they have to do these safety flights before they go up and do actual scored runs. And here we are this far into the challenge, and we still see people coming out, trying to compete. At no point did anybody say, well, I guess I just missed the boat. They're just staying in it until the last minute, trying to get information, gather data, learn about their aircraft, learn about their capabilities, and then potentially win the prize.
Are you surprised there's not more teams representing academia? I mean, I feel like we should have teams from Stanford and Harvard and MIT all out here, because $2.5 million if you win, or even in the top 3, that pays for a bit of tuition.
You know, I've been thinking about what makes people make the decision to come here versus not, and there's a certain type of person, and I admit to being one of these people. If you ask me to do a challenge like this, I would look at the amount of time that so this whole thing was put together in 11 months, and a lot of these teams had significantly less than that because they just didn't find out about it on day one. I would look at the timeline and say, I couldn't possibly be ready to go. Maybe I'll do it next year, except there isn't a next year. And I have a lot of respect for the teams. Some of these teams just said, I don't know, I'll try. And they're just going to give it their best go and see if they can accomplish something meaningful. So anybody who decided it wasn't in their interest to come out, I certainly understand that perspective, but I'm glad there's people in the world who say, damn the odds, I'm just going to give it a go.
But don't you think at some of the top universities in this country there are students and kids already messing with or doing things with drones and aviation?
Yeah, drones, aviation, sure, but this specific challenge is so outside of what people normally think about. The idea, number one, that we're going to focus on payload to weight ratio is a novel way of approaching this problem, trying to reduce that dollars per pound per mile to make this type of lift more accessible to everyone. And I think there's just a lot of people who haven't thought about this problem in this exact way.
These are basically aviation problem solvers as we look at Phoenix drone out of Phoenix, Arizona. This is a check flight for them as well. We've seen them go up in the air and come back down. We'll see if they decide to attach some serious weight to this as we continue. I don't say completely hold our breath, but we are waiting with some bit of anticipation to see if we get to the 4-to-1.
Todd, I'm going to interrupt you. Do you see that the propeller discs are moving relative to the frame? Sometimes the left one is higher and sometimes the right one's higher.
Good point.
So earlier we talked about how a craft like this is going to tilt itself. And what's happening is that disc is tilting left, right, front, back, and that's shifting the direction of thrust that's coming off of it and causing the craft to turn.
So this is lane 5, I'm being told. This is MTech. This is the team out of Sudbury, Mass, founded by MIT engineers and entrepreneurs. So there you go, there's my answer, MIT in the house. And this is a scoring run. How do I know that? Look at the top right of your corner. It says run 11. It is in the green, so they are in the money. They've got to stay above 100 feet. And their
they're
vehicle weighs
getting real close to that
30,
100 feet. I saw 108 on the
32.8 pounds with a 111 payload, so that's a 3.41 payload to weight ratio. This would move them into second place if MTech can make this happen. They've got to go 4 nautical miles, maintaining a height above 100 feet, but not exceeding 200. And if they can do that and drop their weight and then do another nautical mile, they are in the top 3.
If they do go below that 100-foot floor, they can just come back and land and try again, assuming that they assess their odds,
and they have the fuel.
Yeah, well, they probably just slap new. Nobody's gonna start a run with less than fully charged battery because it's just a waste of weight. You would just use a smaller battery. So these guys surely have tons of spares.
Okay.
The question would be whether they got close. They're at 117, 107, 104, very close to that 100-foot floor. They really need to stay above that. And the question would be whether this is a piloting issue. These pilots are very, very skilled, but it can be just very difficult to gauge the aircraft's altitude when you're looking at it with your unaided eye. Of course, they have access to this telemetry data, but I've been told by some of them that the telemetry data is a little bit delayed, and so they may lose altitude before they realize that they're doing it. So the question would be whether the pilot is just kind of getting dialed in, or whether there's an issue with the aircraft that's making it hard for the pilot to maintain.
This doesn't look promising. I don't know if that's on a turn or something like that. That seems like they've struggled as they've gone over 1 nautical mile, so they're still above the 100. That time they've dipped down to 110, so getting a little too close maybe.
Yeah, and in an event like this, you can assume that any sort of sudden movement like that is almost certainly unintentional. A sudden movement like that,
and they've gone below.
Yeah, a sudden movement like that is going to increase stress on the airframe and waste fuel, waste battery.
Yep. So the green has gone away in the top right corner, so they have to come back. And to my point, or what I was, I guess, trying to allude to and ask you about, JB, was do they have the battery, or will they come back and change the battery out because they've already run 1.1 nautical miles?
Yeah, so presumably, certainly they are starting with just enough battery to finish the course and then a little bit more for safety, but they would not have enough battery to do a nautical mile and then go finish the run. They simply wouldn't. They would run out of battery. But they almost certainly have a ton of spare batteries. They're going to land. They're going to assess the situation, and obviously you don't want to just go up and have the same thing happen again. But I'm sure they'll be ready to go as soon as they can.
Now, if they can complete this, and there you saw what they did, 1.1 nautical miles, so that would put them around 16 minutes for the 4, maybe another 4 minutes for the 5. So that would put them around 20 minutes total time in air with the payload, and depending on how much time it takes for them to take the weight off, do that last nautical mile without the weight. It'll be interesting to see how they get that done. So we'll turn our attention from them to Phoenix, who is still in the air, and there's the announcer Jinx, but nice save.
No, I don't know
Maybe
if it's
not a nice
yes.
save.
And so then just at that last minute, I saw that bottom rotor stop spinning. So they had some kind of a problem with that rotor. It stopped making thrust. It stopped spinning. It dropped It almost recovered, but if you have two rotors, you can't fly with one of them
and
gone.
the problem for Phoenix now, and we pointed this out for safety reasons, because they did not land near their landing zone, they are not able to go retrieve that until the flight window is ended for safety reasons. Obviously, you can't be walking down range with drones carrying 100-plus pounds. So let's look at this one more time. You spotted one of the rotors shutting down?
So look at the lower rotor. You can see the right side dips, and that indicates that rotor has stopped making thrust. It almost recovers. And then keep watching, you'll see it stop spinning just before it hits the ground, and that indicates they were certainly having a problem with the motor.
Yeah, right there, I thought they saved it.
The right side dips again, and there you go. You see it slows and loses, So what likely happened there is when it was loaded by the weight of the aircraft, it was struggling. When it dipped, it became unloaded and picked up speed again, but then, of course, as soon as it recovered, it was loaded again, and they had some kind of a problem.
So do you think that's a situation where Phoenix maybe got a little overambitious with their payload and it was too much, or do you think it was more of a technical issue?
The thing is, if you asked me to design one of these, I would design it with lots of safety margin because I don't want the motor to perhaps overheat and fall out of the sky. But the entire point of this is that we're pushing past those safety margins to find what we can do in a safe way, in a situation where a crash like this doesn't put anybody in danger. But the whole point of this is that we're going to find out what the limits are. And sometimes when you push to the limits, you find, oh, there it was.
Oh, look at that.
Yeah.
See the exhaust, something burning up there on the left-hand side.
New. Yeah, that's the motor smoked.
Yeah.
So that was presumably an electric motor. And when you make an electric motor work too hard, the smoke comes out, and then it's done.
I thought they had a nice save there about halfway through that rapid descent, and maybe it cushioned the blow a little bit, but by the looks of that debris, maybe not enough.
Yeah, no, that's a bad one. So if they have a second aircraft, they could put it up. If this is their only aircraft, it seems likely that they're going to be done for this flight window.
So that was Phoenix Drone out of Phoenix, Arizona. Veteran-owned company of Honeywell scientists and engineers with several decades of cumulative UAS and RC and manufacturing experience. It looks like their flight window has come to an end. See who we've got up here. This is lane 14 now. Another team out of Phoenix, VertSolve, led by Kevin Horm, former United States Air Force officer and the primary designer of the aircraft beyond DLC. They are excited to continue development of the aircraft for defense and civil uses in the United States. So back-to-back teams from the Grand Canyon State.
Yeah, you hear me make a little noise there. Seeing the drone, it's moving relatively fast for what we've seen in this competition. It's fully stable and fully in control, and then we saw it tilt back the other direction, and as it was sliding, here we go, nice slide, everything looking good and in control. I say that, and then immediately,
announcer jinx.
We see the opposite.
Well, it is.
We're missing a landing foot off that right side motor.
Something flew off.
That landing foot shouldn't affect the way the craft flies at all. So it's a little unclear why they had an issue. This was a scoring run.
Yeah, they've dropped below 100.
Yeah.
So it was a scoring run. They'd only traveled a very short distance, not even half a nautical mile, minute 30 in, and you notice the dip and then missing part.
Yeah, you know, I want to call things out when I see them, but I don't want to jinx anything. Everything's going great.
Yeah, it's too late. Everyone wants to get the JB jinx.
I'll just sit here and be quiet when things are going well. I'm not saying anything.
Not a chance. Pay you the big bucks to talk. So they've got the 3 landing points down.
Yep. They're missing one.
They're missing one.
Yeah. So
remember Top Gun Maverick, the second Top Gun movie, when he comes in on that old plane and he has to come in missing landing gear? That's how you do it.
Yeah.
You just go soft.
Yeah, just go belly land.
Little heavy.
You know, with an airplane, when you do a belly landing, you're scraping the belly of the plane against the runway. With a multi-rotor like this or a VTOL craft,
there it is.
You come down and
right side, and
does it get in the prop?
Nope.
It does not.
Eject.
It was unclear why they lost stability.
But you don't think that's enough weight change to?
No, not at all. Not even remotely. Yeah, so like if you're missing that landing foot, you just set it down in the grass on the belly. Usually you would design a craft like this with nothing underneath it that would be damaged by a landing. And so generally those landing feet are more for convenience than anything else. Get the props up out of the grass a little bit. No, it's no big deal to land it.
This is Aptos Aero out of Berkeley, California. Engineering studio based in Berkeley. Jean-Francois Clevrier, mechanical and aerospace engineer with 25 years of experience in designing, prototyping fun vehicles. And this is coming down.
Yeah.
Oh no, I thought it was coming down quicker than you probably anticipated. And
we got a wobble though.
Rapid descent.
Rapid descent.
And
he's still in.
Look at this, still in the game, and then skeleton walk.
Oh, I'm really impressed with honestly how well those rotors seem to take that treatment. They were stronger than I gave them credit
worse.
For. Oh, for sure.
We've seen a lot worse. So, all things considered, but that is downrange. So, unfortunately, Jean-Francois is not going to be able to walk down there and pick it up and bring it home.
And the first thing I noticed was this shaking while it was flying. Anytime you've got an oscillation like that, it is not a good sign. Your craft is going to have a lot of trouble flying. We see it hit the ground here and bounce back up again. And at this point, as a pilot, I'm just like, no, stop, stay down, stay down. I don't want to damage those rotors because that, of course, is the most expensive and difficult thing to replace.
Looked like they flexed, but I didn't see a break.
Yeah, and they could be intact. We don't know if they took some kind of damage that renders them unusable.
Yeah,
but they look pretty good from here.
We won't find out till later. So Aptos will be making some fixes there. Meanwhile, we look down the flight line. That's a lot longer than it looks. That's probably, what do you think, half a mile?
Could be.
That's some distance.
Yeah, it's some distance. We have 15 flight lines here, all separated by enough space that the competitors can fly down and back and not put anybody else in any danger or danger of affecting their runs. Of course, the pilots over behind those safety barriers on the right side, so that if any debris comes back that way, they are protected. And a whole lot of other procedures that I won't go into just to make sure this whole thing comes off without a hitch.
It looks like MTech is prepping for a qualifying run here. The team out of Sudbury, Mass. MIT. Come on. MIT engineers and entrepreneurs. I'm not saying you're betting, but I think they're odds-on favorite with that kind of brain power.
Yeah.
Look at this.
MIT is very smart. I'm not allowed to say that because I went to Georgia Tech, but
you went to Georgia Tech.
I did.
Rambling wreck of Georgia Tech.
That is right. Known for our sports teams.
It's a good school, though.
It is.
Man, talk about wasting no time.
Yeah, back in the air. And we have I can't count them, it looked like more than 4 motors, though. So that probably means it's 6 or 8. We have more motors with smaller props. Todd, if you think about, you have a given sort of circle that your drone has to fit in.
Correct.
Right? You can have a lot of smaller props, or you can have one very big one, and there's different engineering trade-offs to that. Larger props being more efficient, smaller props in some ways being more durable or more maneuverable.
So this is MTech Operations out of Sudbury, Mass. This is a scoring run. You see the green in the upper right corner. Their altitude holding steady at 150 feet plus. And there you see the payload, just under 112 pounds. That vehicle only weighs 32.8 pounds. So look at the payload to weight ratio, 3.41. If they can complete 4 nautical miles, come back, drop the weight, go back out, do 1 more nautical mile while staying above 100 feet, this would put them into 2nd place.
Yeah, the big question with a design like this with the smaller rotors is you're going to get a lot of lift and a lot of thrust, but it's going to be inefficient and you're not going to have the range or flight time to finish the course. We've seen some teams trying new battery technology to try to get that payload to weight ratio and try to get that battery energy density up in a range that lets them complete the 5 nautical miles. But the way the competition's been designed, you know, if you could lift a weight, but you can only fly at 500 feet, that's not very useful. If you can fly that weight 5 nautical miles, which is about 5 or 6 regular miles, that's where you just start getting into distances that it's actually useful for real-world application.
So we're about 34 minutes into this flight window. It kicked off at 12 o'clock Eastern time here in Dayton, Ohio. And you are looking at MTech on a scoring run. And they are at 122 on their altitude. Their time looks good.
Those turns are looking smooth and undramatic. The smoother you make those turns, the more efficiently you're flying and the less stress you're putting on your airframe. And basically, the greater the odds of success.
Do you think the parameters of what they're asking them to do is about where they should be? I mean, four nautical miles plus drop the weight plus nautical mile, is that a sweet spot?
Yeah, I mean, this is, the more I thought about it, the more I realized that it's not just an arbitrary number pulled out of a hat, that a lot of thought went into making it just difficult enough that it was a challenge, but that it was still achievable with today's technology, and then that it was just enough that it would be producing a usable result. You know, if you said make an aircraft that can lift for 50,000 pounds, that's going to be useful to a few people, but it's not going to help me get my groceries from the grocery store. So by focusing on an aircraft that weighs about 55 pounds, that's that FAA limit, and then can lift in the range of 100 to 200 pounds, if we could unlock that and make that cheap and affordable, that's going to unlock a whole lot of possibilities.
You've referenced several times, and I know Donna's been on the set with us and referenced several times the example of groceries, and I think a lot of people think applicable ways to put this into common day life would be, you can't get out, some kind of situation. I order my groceries and a drone comes and drops it off at my front door, and we look at, I don't know anyone that's getting 110 pounds of groceries. I guess if you're going to one of those big warehouses you are, but 40, 50 pounds of groceries is about right. And so that means that MTech has now come off a scoring run as they've gone below 100 feet, and they're going to bring it back. So they're going to bring it back, and they're going to set it down. And they are home safely.
Yeah, and they can recover, and they could assess and potentially try again. Again, credit to the pilot.
Yeah,
he didn't set it down in the grass.
He wants to put it dead center, perfect, or close to it. So there it is. Okay, so MTech got up for a little while, gave us a little hope, and then they brought it back down. So something obviously for them was not exactly where they wanted it to be, and maybe it was a weather situation. As we're sitting here right now, there is some serious gusts coming on. You look in the distance, it looks like some thunderheads are in the distance. Doesn't look like we're supposed to have any serious weather until after today's flight windows have closed. These are the hovering owls that are up again. This is the team from Florida Atlantic University in Boca Raton, Florida. If you saw that flying over your house, now you're a drone guy, so you wouldn't think any of it. I would think we're seriously talking about like World War Z. This would be like a War of the Worlds situation.
Yeah, it would be very unusual.
Unnerving
to see something like that flying over my house.
And if I found out it was just my friend getting his Amazon shampoo delivered, I'd be really perplexed.
Well, that may be the kind of thing that becomes more useful. I mean, cars perplexed a lot of people who rode horses.
True.
Us old guys, whenever something new happens, we shake our fist at the sky. But that's not the perspective of here at the DARPA Lift Challenge. These people want to sort of define the future, push the possibilities, and create new stuff.
But to your point, it is so true because, and we're here in Dayton, Ohio, the home of the Wright brothers. Can you imagine the first time, let's say you're out for a stroll, Kitty Hawk, North Carolina,
right?
And all of a sudden you see these jokers and they're flying a biplane-powered plane, and you're thinking, what in the world is that?
And think about all the things that manned aviation made possible that we take for granted right now. The ability, like you flew here from London.
Yes.
The ability to come from another continent here in just a few hours of travel time.
Yeah.
Nobody could have imagined that stuff at the time that the Wright brothers were doing their first flight.
Oh. And you think about what's going to be in 20 years.
Yeah. And we don't know what kind of things this improvement in payload to weight ratio is going to spark and make possible that people 20, 50 years from now will take for granted.
What is the coolest, and this is a little bit off topic as we look at MTech working on their craft right now, what do you think the coolest piece of aviation technology is in your lifetime? I know it's a big question, so I'll let you percolate on it just a little bit. But as you look at being here at the National Museum for the United States Air Force and talk about some of the great planes and aircrafts that are inside those hangars, what do you think is the coolest, I don't say innovation, invention that you've seen in your lifetime? What, you're 21,
Aviation,
22 years old?
I mean, from my perspective, I'm a drone guy, so obviously I'm going to give a drone-related answer. Some of the companies right now that are working on, they call them flying cars, and they're basically small one-man multi-rotor aircraft. Or in one case, there's a company that makes what's called a flying motorcycle, which is, you can picture that.
Love that idea.
It's so cool, like as somebody who flies drones, and then you have the camera and you're quote-unquote in the drone, but you're not really. The idea that you could have something like that scaled up to the size that a human could ride in, and then instead of having like a helicopter, which you wouldn't take a helicopter down to the local fast food, the local grocery store. Something small and reliable that you could actually use for personal aviation. That really excites me.
And you make the correlation of, it's small and personal in a helicopter. Can you ever get that point? Well, you go back and you think of 50 years ago, if you had a computer, you were a massive business and it took up a whole room, just that one computer. And now we have more power in the palm of our hands with our phones. But you might get to that point where you have a personal aircraft and I just need to run down 20 miles away. I'm going to just go up in the copter.
And to go back to the DARPA Lift Challenge, that's what's key about this, because what makes computers, etc., so ubiquitous, and we find all these new uses for them, is that they've become less expensive. Originally we had vacuum tubes, computers were very, very expensive. Now we have cheap silicon transistors. We can put billions of them on a chip, and suddenly we can do all these things with computers that we couldn't do before. And if we can get that payload to weight ratio, payload per mile per kilometer down, then that's the potential. All
right, you have plenty of time to think about it. What is your vote for the coolest piece of aviation technology or invention in your lifetime?
It's got to be the
drones.
The car.
The flying car.
The flying car. Now I know that those are still not quite commercialized yet.
Yeah.
But they do exist. People are using them, and I think that is really potentially going to unlock something interesting.
Yeah. Okay. Let's take it out to the flight line, and Happy Hellfire looks like they are ready to go. But I will say, and I'm not trying to play DARPA's version of Al Roker, but the wind is picking up quite a bit. It's gusting a bit more.
You can see the shirt blowing.
The shimmy on the shirt.
Yeah.
So I wonder if they're just going to maybe see if this little bit of pressure passes through.
I'm going to guess that's about 8 knots, just based on the way his shirt's blowing, and that flag. I believe Donna said their maximum for safety was 25 knots, which is a lot.
So each section of that,
I don't
represents.
I don't read it. Yeah, each section of the sock represents some number of knots of airspeed, but I only read shirts and flags.
Where's our Harrier pilot when we need him? This is KC Space Pilots. It looks like they are either starting to wind up, the Pirates, or that is a windmill on the ground.
Yeah.
And that's a windmill on the ground. They're going to come out. There you go.
The officials there bringing it to a stop. Chairs, of course, very important.
That gives me the idea that they're going to be out there longer than a quick check. So the KC Space Pirates out of Kansas City, Missouri, got to bring a chair out for the boss man.
It looks like he's got a laptop. They may be adjusting the flight computer. And you don't want to have that laptop on your lap, hence the name.
He could be checking the standings of the DARPA Lift Challenge, which we can always do for you at any time. Show you exactly who is the top 4 right now in the money. Remember, $2.5 million on the line to the winner if they can hit the 4-to-1 payload to weight ratio. The utility wagon is out there and the whole crew, so I have a feeling they're not going to be going up anytime soon. But when they do, we'll be all over it. The KC Space Pirates out of Kansas City.
I think those little utility carts are the sort of MVP of this whole event. I've seen people pulling them all over the place.
Serious business. So we are coming up on 45 minutes into the second flight window of day 5 here at the DARPA Lift Challenge. 90-minute windows, unless you get an extension. We don't keep you up on that, but 45 minutes to go in this one, roughly. And maybe the weather chased some people away, but everyone's still crunching numbers.
Todd, is the name of this team Space Pirates or Pilots? I've
got Space Pirates.
Okay, I thought I misheard it.
I probably said Pilots.
I like it better as Pirates.
I do too.
Honestly.
Yeah.
And maybe an intentional play on words. Anyway, if the audience is trying to look them up, it's the KC Space Pirates. Arr.
So just getting to the flight line is quite an accomplishment, and it doesn't happen in a matter of seconds or minutes. This is a multi-hour situation. So from the time you're given your flight window, the folks at DARPA will give you a bit of a timeline of when you should be prepping, when you should be rolling out. They've got to go through some checks before they even get to the flight line. So you go through a process before you even get out there. So T120, so roughly 2 hours, you get the pickup. And then hazmat retrieval, which means what?
Hazmat. So when people hear hazmat, they may go,
Yes.
what kind of hazmat? It just means batteries or
fuel,
gasoline.
Okay.
Those are treated because they're flammable.
80 minutes out, you go to the prep tent, you get the preparation going on. 70 minutes out, DARPA comes over and gives you a little prep checklist. You want to make sure you're good to go. 30 minutes to go, you get to move to the launch tent. That's the final review. And then 30 minutes later, you are on the clock.
So I think we're going to bring in D-Material. That is the inflatable drone frame that we saw fly just barely. I was so curious about this because, you know, you think about an inflatable drone frame and you say, well, I've held balloons before. Balloons aren't rigid, they're squishy. And how are you going to make a drone frame out of it? You know? But apparently D-Material has figured it out.
I think they became a meme yesterday because we were talking about, is that soft? Is it hard? Is it this, that? And we were asking, and they were kind enough to come over and meet us when we came off the air, and they took us through and gave us the full lay of the land. And I thought, man, we were getting a look behind Willy Wonka's curtain here because they rolled out the red carpet for us, and we got to see everything up close and personal. They let Joshua Bardwell handle stuff. And I thought, that's the definite kiss of death. You don't want that. He's going to jinx him right off the spot. But not the case. And so the good folks, D-Material, said, you know what? Anytime you guys need us to come on over, do it. And, of course, we jumped on it, and we went over and snagged some of their property, and we got some of their equipment. And in just a matter of moments, as you see them on the screen right now, it is just a cool-looking thing. We talked about it, the water applications right off the bat. But the question is, wow, look at this. Okay.
Yeah. Todd, look at this aircraft flying. Do you see how much it is not stretching or wiggling or flexing or bending? If I told you that was an inflatable balloon, more or less, I mean, you'd be hard-pressed to believe me. In fact, yesterday I speculated that it must have some kind of internal structure.
Yeah.
But it does not.
And when they have a hard landing, not a big deal. It sets down. Look at that one. They got a little wobbly there, caught a little wind, dipped the nose, put it down.
There's nothing to break.
No harm, no foul. They rolled right along.
Yeah.
6 hard landings.
So there we go. And here is the man, the myth, the legend. First of all, before we go anywhere, what in the world? And I want to tell people, this D-Material, it doesn't weigh much at all. What is the total weight on that?
That one weighs 3 pounds, just under.
Max.
As a frame. And we've put 255 pounds on it. It barely moved, and we can easily put over 500 to 600 pounds on it.
So for perspective, what would a traditional frame made of carbon fiber or some other similar material of that size weigh? Like how much lighter are you?
Probably, I mean, some of the ones here are pretty light, but a more traditional commercial one would easily weigh well over 10
pounds. So
and
you're
if not,
basically a third the weight
if not in the teens. And the bigger we get, the lighter weight our system becomes and the less expensive it comes to compared to carbon fiber.
So introduce yourself, your team, where you guys are all from, the whole thing.
Yeah, so we're Team D-Material. I'm from Chicago, and my co-founder, Warren Reesner, and the lead engineer, is actually in Wasilla, Alaska. And we create these rigidly inflatable structures out of Dyneema, which is this material here.
Did I hear you can weld those?
We can RF weld Dyneema, which is we're the only company that can do that. And this material, it's 7 inches wide, and it has these fibers which go into bulletproof vests. So these little white fibers go into bulletproof vests. And if the two of you pulled against this, you would have to pull 2,000 pounds to break this.
Do you want us to do that?
No, I think we won't try that.
I think I saw that on a
exactly.
YouTube commercial.
Now, you went to school at University of California at Berkeley.
I did.
Go Bears.
Go Bears.
When did this whole thing kind of start percolating between your ears and you said, you know what, I got an idea? Did you wake up one night after some, bad Italian and say, I got an idea, and just wrote it down?
Well, when I had the idea of actually I bought the assets of a company named Indemnis that made ballistic parachutes for drones that shot the parachute out at 175 miles an hour and recovered the drone in 80 feet AGL. So, so we are able to take that. And so I basically took that and I was like, they lost their Amazon contract and it was COVID. So I was like, you know what? My wife remembers the day I was running around. I was like, I can make wind turbine blades. I was literally so excited. It was crazy, all the things that I could do. And basically, I've always wanted to take this technology and bring it into the structural applications, right? Drones being the one where lightweight, packable, scalable. I could manufacture these in an automated machine at 1,000 a day.
Wait, talk about packable. What do you mean? How is this packable? It's enormous.
So that packs down into, and I wish I would have brought it, a little tube that's about yay big. And
gotcha.
so that tube does not have structure, which we talked about, and it just uses an air compressor.
That's awesome. Well, thank you so much for bringing this. D Material, we wish you the best of luck. Give me the odds on that you're going to walk away with the top prize.
We are not going to walk away. We didn't do that, but we do want the prize for most commercially potential.
Okay.
Most commercial
Awesome.
potential.
Thanks again,
Thank
my
you.
friend. Good to see you. All right, we're going to go back out to the flight line. We've got a comp run in progress, and this scoring run is going to be, this could be something. JB, this could be something. But how about D Material? I mean, that was awesome. That was super cool. Great intel. Appreciate them sharing that.
I think we should just leave this out here for a little while.
So MTech now out there, and we'll see. Top right is green. Good news is they're above 100 feet. Payload 111.9, 3.41 payload to weight ratio for a vehicle that only weighs 32.8 pounds. Remember, it's a 30-minute time limit. JB, that has not been an issue in the past, so this looks pretty good.
Yeah. I mean, they all look good, right? Well, that's not true. I was about to say they all look good until they don't, but some of them barely get off the pad. So the fact that they're up in the air, they're flying smooth and stable, and they're just working their run. They just got to keep doing this for another roughly 4.5 nautical miles.
Remember, we saw them last time. It was the turns that was kind of an issue, but maybe they've sorted that out.
Yeah, so they're trying to be at higher altitude this time. They were losing altitude in the turns, losing stability in the turns, and we saw them actually dip hard. Here they're, again, 123 feet. That's getting awfully close to that 100-foot floor, and if they go below that, it will end the run.
So coming up on 1 nautical mile complete for MTech operations. Again, they're at 3.41. That's the payload to weight ratio. If they complete this, folks, they would go into second place overall. Remember, first place, if they hit the 4-to-1 ratio, it's $2.5 million.
So here they're climbing 190, 192. They can't blow that 200-foot ceiling either, just barely. They may get away with that. It looks like what they're doing is they're climbing. They know they're losing altitude in the turns, and so they're intentionally climbing up and then making the turn. The upper right is still green, Todd, so that does mean
that's a good sign
that the competition run is still going.
So MTech now at the 3-minute mark. Again, they have a 30-minute max. And I guess the big question is, it's not going to be completing it, JB. It's going to be the removal of the payload and then getting them back up again. MTech, again, out of Sunbury, Mass., founded by MIT engineers and entrepreneurs. We got lots of questions, and the man to give us lots of answers is the program manager for the DARPA Lift Challenge. Of course, we've got Philip Donna Smith, call sign Donna, now a reservist, former Harrier pilot, kind of knows a lot of things about a lot of things. Donna, welcome back. We missed you. We missed you in the first flight window, but you're back.
Yeah, what happened? I wasn't even able to see it.
You went full MIA on us.
No, I was doing other things. I guess that's what happens when you run it. You get pulled off of the fun stuff.
When you're a program manager for this. Yeah, I get it. First of all, before we get to what MTech's doing here, what were your thoughts and takeaways from that morning flight window?
No, honestly, I haven't seen anything.
You haven't seen anything?
I did not see
the
window.
Tell you someone
so you tell me what your thoughts were.
Go. We had some movement on the leaderboard, which
yep.
was good. We had some new data received by some teams that took some heavy landings.
Good.
But other than that, it was pretty awesome.
Okay.
I think I'm going to do that. I think we should just have new data received as a euphemism for a crash. How would your flight go? I got some new data.
What do they call it? Unplanned disassembly or something like that? Yeah.
So here we go. This is MTech. You see the time.
3.4, that's good.
That's good. Payload to weight ratio. This looks like they're having no problem at all. Although their altitude is, they are just, now if they go over 200 for just a second.
That's it.
That's it.
That's it. So they just have to redo the run.
Okay.
Now for an electric one like this, in the heat, in the sun, the problem with that is their components are already heated up, right? Because they just did a run for this long at these powers. And so if they just come down and swap batteries, they have a real issue with their electronic speed controllers and their motors overheating. What happens with the electronics there is that you'll have that power settling. So you'll start to see when they take off, and this happened to Defentex yesterday, right? They took off, and then all of a sudden they kind of just hit that limit and they started settling down. So that's what you can see here. On the gas-powered, all the gas-powered, whether it's the turbines or the motors, they want to go in the coldest part of the day, right? So the density altitude is better. They get cold air in, right? They compress it. They squirt in the gas, and then it comes out at a higher pressure, and that's what turns those blades in that turbo shaft. So there's so many things here that make this competition really fun and interesting, and that's some of it, right? So electric batteries really just want to be in the best window. They don't want to be hot. They don't want to be cold.
Sweet spot.
The sweet spot is what they want. Fuel engines, they want to be as cold as possible to get that compression ratio for pistons or the compression for the turbines.
You raise a good point, which is that brushless electric motors get less efficient as they heat up.
Correct.
So this idea that somebody's going to make half a run, come in, land, swap batteries, and jump up again, they're immediately at a disadvantage.
Correct. Yep. And so that's why this altitude window is so important, right? So if they break that, then they come back down, they swap batteries. You don't know what it's going to be. You don't know what it's going to be that next time, and that's where the real risk comes in.
Okay, so we're keeping an eye on MTech. It just seems like they flirted not with the altitude of the bottom section of that. It's the upper
top,
section.
right?
Yeah, it's with another drone cutting right in front.
Yeah, and again, there's spacing. What's the spacing between those lanes, Donna?
It's a good bit. We haven't seen. So one drone on one of the days, actually it was the only drone flying, thankfully, but it did dip down below the altitude, so it was below that 100-foot block, and then it came all the way over to the left. No issue there, but so far we've seen plenty of spacing between the aircraft, even with the systems, right, the orbiting ones, we've seen plenty of space in between.
So we talked about the hard deck being 100 feet, the max 200 feet. MTech has certainly flirted with that max, but they still are green top right, so we can take that as they're still good to go?
Correct. Yep.
Okay.
So, Donna, we've seen this drone having trouble during the turns. It seems when it makes a turn, it loses a lot of altitude. We see them now climbing before their turns.
Correct.
Do you have any thoughts about that?
Yeah, so remember yesterday when we talked about total power available. So total power available is just the max. Everything running at 100%. Actually, in motors and engines, you actually go above 100%, which seems funny, right? 100 is all you should get.
Yeah.
But 100% is actually the manufacturer's, RPM, right?
That's what the manufacturer thinks you should
right,
do.
The rotation, the suggestion.
Yeah.
And that's just a suggestion. But RPM, as a reminder, is rotations per minute. So that's how the motor is coming from the factory. So what we have to do here is go to 200, 300, 400% on these motors and really test them out. And no one's really ever done that. I've heard teams of calling up, not that no one's ever done it, but no one's ever done it with this kind of a challenge, right?
Yeah.
Or this money on the line.
Well, there's not even an incentive.
There's no incentive, right? And there's no manufacturer warranty when you go above that 100% either.
Right.
So yeah, that's what they're doing. They're testing every single part, pushing it as hard as they can. But coming back to that power available, so when the aircraft is flying nice and flat, it's getting some other aerodynamic forces, but all of the motors are going in one direction. In order for them to stop, they have to not only stop the weight of their aircraft, but the momentum that they created, right? And also, they have to maintain stability in that turn. So they actually, instead of, we'll keep 100%, but instead of flying back and forth like this, maybe they're at 90%. When they slow down, as you see here, they have to go up to that 98% or whatever. That's only 2% left for control.
Yep.
So you got to have that ability. Now, if on that run and with the temperature of their motors and batteries and all of the other factors combined, they said, okay, I'm going to go, in this case, at 32, 33.1 miles per hour. I can make that hockey stop at the end. Then that's what they program in. That's what they think. But there is no data to go back to that. There is no manufacturer spreadsheet that says this is how the motor and the battery will work. So it's an educated guessing game.
Well, and it's a moving target because
Correct.
the motors heat up, the air density changes, et cetera, et cetera.
So you hope, and you hope that, okay, you start out maybe when everything is cold, you start out at one speed. A lot of people, I haven't been seeing it, but adjusting their speeds as they come into that hockey stop in order to save a little bit of that power for control. So that's what you're seeing is at that hockey stop, they may peg out whatever they can get out of those batteries and motors in this case, and have nothing left for controllability. And so that's where you'll start to see that settling, which now, as we're talking about it, may be the reason why these guys are at the top of their window, right? So if you're at the top of the flight window and you start getting that settling, you have 100 feet, right? Or 90 feet to be able to save it before you break the box, break that boundary.
Is that landing acceptable?
Yeah, so they're coming in to drop weights. They've done 4 nautical miles. They're coming in to take the weights off. Are they required to land on the pad?
Yep. So we'll see what the lane coordinator says. But from here, armchair quarterbacking
there you
here,
go.
the center of the aircraft does have to land on the box. So it's easy on this one because the weight plates are the center of that aircraft, the CG, center of gravity. And so the hole in the middle of that weight plate needs to be on the wooden platform.
So we'll keep an eye on the upper right-hand corner of the screen to see if that stays green, which will indicate that the scoring run is still on. They're repositioning. I guess they wouldn't have moved it if they hadn't made the call.
Well, either way, if they have to run another lap or this one is good, they're going to move it back to the middle, right?
Yeah.
So we'll see. They take off the weights. They might want to do this to say, hey, I just got through 4 miles. I want to see how much battery life is left because I just did that. And
take
then
the data
just
off
run,
that, yeah.
run the last mile, get the data and say, yep, everything else was good. I can complete and then try it again the next time.
But this is kind of a big deal because if this stands and they do the last nautical mile without the weight, they move into second place.
Correct. Yep. So we'll have to see what the ruling is on the field for that. If I was that team and I got that far, I would want to finish the mile, even knowing that it was invalidated because of the landing.
Just to know that you
just to know that you can.
It's not going to take that much longer.
What they also found out is with that weight in second place, they can finish.
Yeah.
Which now means the next one they go up 5 pounds and they increase it because they know that the aircraft was successful in today's conditions this moment. So now hopefully the conditions don't change here in the next 20 minutes, but they'll be able to put it back on and even go higher on the weight.
Yeah, I'm surprised to hear you say that. I mean, knowing that you could do it, but you didn't. Why wouldn't you want to, maybe just like take the win and then go up 5 pounds?
There's nothing like first place.
Yeah. Okay.
If you're not competing, you're not trying.
That's the attitude.
There's a Ricky Bobby reference in there somewhere.
There's somewhere, right?
So they would move into second place if this stands, if they complete the last nautical mile without the weight. Again, this is M-Tech out of Sunbury, Mass. This is Philip Smith, call sign Donna. He is the program manager for the DARPA Lift Challenge. Basically, he's the man in charge of all this chaos and beauty all at the same time.
All at the same time.
Did you think 11 months ago, was this the envision that you had? Is this coming together about where you wanted it to be?
Yeah, and in so many ways. So the full vision, when I came here Wednesday of last week, and I drove through the front gates, I was amazed. I was like, what? This is what we did? We set all this stuff up. It looks amazing. So the scale is hard to see. You can kind of see it from the aerial drones, but when you're on the ground and seeing everything that's set up, so that's amazing. The teams have been amazing. The things we hoped that they would do, which is gelling together as a community, is happening. The flights are happening. We are so close to that 4.0. I don't know if they're just playing with me and just like, no, we're going to wait another day or two. My emotions are all over the place, but
would you prefer someone to get it done and then everyone start chasing 5?
I could relax a little bit more,
exactly.
No.
Let me ask you about that. I'm sure that you had a lot of meetings and a lot of discussion about what the numbers should be, and I think you argued for 4.0. Seeing how the competition is playing out, do you feel like that was the right number? Or do you maybe wish you'd gone a little lower or a little higher?
Yeah, so I had a lot of experts come to me and say you should make it at 3. 4 is too high, and it's not. No, you're not going to get teams that want to try, and then when you get there, it's going to be a big failure.
Right.
We
but we
currently
had
have
some
three
other
teams above 3 right now. Sorry to interrupt you.
Right. So we said no. This is a DARPA challenge. We have enough evidence to say we think it is possible, and it was so far from what people already thought was possible that it was a good medium, right? We really hoped, and now we're seeing how close and how many tries it takes and how many rebuilds it takes. But that's the point of this. That is the point, is to change people's mindsets from this is not possible to it is possible.
We all keep receipts. I'm just wondering on Monday if you're going to make a few phone calls, say, what was that you said about not a chance? We hit it, not a chance.
No. See, this is why we have the broadcast. I don't have to make calls. I don't have to make calls at all.
All right, so we are waiting to see if MTech is going to go back up, if this will count. Again, they completed the 4 nautical miles with the payload weight ratio, which would put them in a second place if it stands. As we give you a good look down the flight line here, and there they are, unweighted.
I think there's good odds that if they completed that 4 nautical miles with the weight, some of the aircraft really struggle when they're unweighted, but one of the advantages of a multi-rotor like this is that it is a little more immune to weight changes than some of the other designs that depend more on like aerodynamics, weight and balance and so forth.
Donna, you know it's coming up at 2 o'clock, don't you?
A lot more flying.
Spitfire's coming up at 2 o'clock.
4, right?
I thought someone told me 2 o'clock. I could be wrong. You would probably know more as a program manager.
So we've got 3 of ours that we're really looking at, and we've moved them all to the 4 o'clock brief. So I'll be back during that time, sitting here with you guys, watching them. And then we're also going to do, I think, a number of replays from the last couple of days, talk about some of the amazing aircraft. And we just found out this morning that someone who crashed and burned spectacularly earlier on they drove 8 hours home.
To Maryland.
Yeah, University of Maryland. You guys already talked about that?
We heard about this. They went home and fixed it, and then they drove back.
I didn't realize that they'd crashed and burned.
Oh, it was a good one.
Spectacular. That scorch mark on the field. That's
one of them. One of the many scorch marks on the field. But if we have that replay later, that'll be great to watch. But we were really excited for them, seeing them fly. We've seen a number of prop-driven rotors, and they've been, whatever. They've been having troubles with controllability. So University of Maryland was the only one that we saw, which was like, what did you guys do? What is your secret sauce on your controllability that you guys are rock solid? And it wasn't even a different fly window to blame it on weather or winds or something. It was the same exact one. So we're really excited for them.
All right, so here it is. Donna asked, and we deliver. Look at this. This was...
So that is right at the end. Yep. And here we go. So it starts one of the batteries. And,
that is a battery fire, not a liquid fuel fire.
Correct. That is batteries.
Woof.
One lights off. Another one lights off.
Then they all go.
And then they all go.
And then it's the 4th of July.
And we lost a tracker to that one, too.
Oh. Full scorched earth. So there you go, JB.
There's the scorched earth right there.
And so they drove back to Maryland.
Yeah, 8 hours back.
Went to work.
Yeah, and it's a 24-hour curing time, I believe, for the epoxy or the materials that they had. They fully rebuilt that wing.
They didn't just go back and get another one that they for some reason didn't bring. They built another one.
They built another one and transported it back. Apparently overnight or something. I don't know. We'll see.
Oh my gosh.
The dedication and that team, the 4 of them, they had the best attitude. Their aircraft was still smoking, and I went up and talked to them. I was like, I want to cry for you guys right now, and they just shrugged their shoulders and said, well, number 2 will be even better. And we're like, all right, there we go.
Yeah.
I'm sure they did not break any speed limitations on their way back to College Park.
No. You say the prop-driven rotors have been we've seen a lot of those out here, and they've been having control issues. And the prop-driven rotor is not a new idea. It's existed in the world, but it hasn't been feasible. And it's really exciting to me, and I wonder if you'll comment, to see these people trying these ideas that have been written off and trying to make them work, because we don't know how good it will be if we get it to work.
And that's the thing. So way back in the 50s, they were doing, Howard Hughes famously has his aircraft. That was actually tip jet, right? So it was a different concept, as we see MTech taking off again here. So it was a different concept, different control theories and everything. The prop-driven rotors, there's some YouTubers who have been able to make that work, and that really inspired, I think, a lot of teams to look into that technology again. And you know, for me at DARPA and an aviation enthusiast and an aviation developer, those are the type of ideas that I really look at.
Right.
Because the base theory, the physics and the aerodynamics of it say it should work better. It should be better. And now what we have to do is just grind through the issues that you find with a brand new development like this.
Yeah, this is very interesting. One of the people out there is not the pilot, but the guy holding the tablet appears to have a set of FPV goggles on. Maybe he's monitoring the flight via the goggles? Is that the pilot? Or does he have the tablet?
It does look like he's not actually flying, right? So he's just got it there. He's probably the backup pilot. You see that the other RPIC just touched that tablet, which you can barely see on the table. So it is autonomously flying at this point.
I see.
But, oh, look, so the aircraft started doing a spinning movement there, and that backup pilot saw it and was about to flip on and take over control.
We've made a point previously that the pilots are flying via line of sight, so it's very unusual to see him with these FPV goggles on his head.
So it was an option. We gave that. Obviously, the camera adds a little bit of weight, but if you don't care about that, you can take a couple of ounces and the radio that's required to make it work, then it's okay. We were talking to those guys out there on the line, and what's interesting about this design is, you know, just watching it on TV, which way is forwards and which way is backwards?
Oh, yeah, no.
You have no idea, right? So a computer knows, and flying this is the only way to do it would be FPV. I remember you talking about that yesterday. So knowing which way is forward and backwards from the ground is almost impossible, so you would have to control it with FPV.
Interesting.
So they're coming up on the 5 nautical miles. Remember, this last nautical mile is without weight. Their payload was 111.9 pounds. That gave them a 3.41 payload to weight ratio. If they succeed and if they get this validated, they would come in and they would move into second place.
You know, knowing that this is being done somewhat autonomously, that a computer is like flying it from waypoint to waypoint, also adds another variable to the altitude control. It may not just be that the power system, but the computer itself is having trouble managing the altitude.
Now you add in GPS drift. There's a number of things that come into autonomous flight.
Altitude measurement on these
See
drones.
there, like, it just started spinning. It's funny when you see that and you think about the computer. What is that computer brain thinking? Why did it all of a sudden just spin like that? We don't know. They probably know once they get through the data, but
very close. Coming up
very
on
close.
5.
4.97,
There we go.
4.98. Yep. So they do have to land on the pad, as we discussed.
So
to end their
unofficially,
run
they've completed the
successfully.
5 nautical miles, and now it's bring it home time.
Gentle, 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 gentle. Oh my gosh! Do not. Okay, it wasn't.
Still at 100.
It looked lower than it was from that shot. I want to see him get it.
Coming in for the landing. Here we go. This would put them into second place. This is MTech out of Sudbury, Mass.
Oh,
that's
good.
That's pretty
what
rock solid. There you go.
That's what you want to see.
All right.
That's
High
what you want
fives
to see.
all the way around.
Yeah.
So MTech officially goes into second. Here you see the 3.41 payload to weight ratio. They decide not to land on the Spitfire landing zone that was scorched yesterday.
A little bit of
They
fire.
said, you know, let's just go to the other one. It's got a better luck of that one, but it is, it's got to feel pretty good. Put
So-
yourself in the top 3.
Yeah, so that's actually, those are the rules there. So the closer one is your landing and takeoff, and then you drop the weights in that farther
Okay.
one. So that way, if the weights are left there, you can do the mile, come back,
that's
and not
really
land
thoughtful.
on top of the weights, right?
Yeah.
And there is the new leaderboard now, top 5. Avadrone's still leading with a 3.84 payload to weight ratio, but it is now MTech who moves into second place ahead of Extreme Aerial Concepts. That's your top 3. H Squared drops down to 4th, and MacGyver rounding out your top 5.
And we have all 3 of the top 3 now beating that 3-to-1 ratio that quote-unquote experts told you was
That's enough.
You know,
Don't
in
go
a,
higher.
In a way, they were right. That is achievable.
Right.
And 4 is apparently very difficult.
Very
and
difficult.
I think
so
I know where you wanted to be.
we hit the requirement there.
Yeah.
Well, that makes you happy. I mean, you weren't able to be here for the flight window in the morning, but you came here for the good stuff.
I got to see some
Yes,
fun
you must
stuff.
be the lucky charm.
Yeah.
Good to have Philip Smith, call sign Donna, with us, the program manager for the DARPA Lift Challenge. This is day number 5. We've got 2 more full days. It sounds like the weather's going to cooperate over the last 2 days.
Hopefully. You never know with the weather and the summertime showers and all that sort of stuff. We might get a little bit more this afternoon. We're hoping it blows by us, but we'll just adjust as necessary and keep on going.
Yeah, what happens if a flight lane gets rained out or something? How do you deal with that?
So we look at it minute by minute, and then there's a number of things that we just
Happy Hellfire.
Happy Hellfire.
Oh, they were up and they were down.
Up and down. All right, we're gonna get a replay
yeah,
here.
I think, and I'm just speculating, but it is gotten a little bit gusty as I look
They're
at some of
going
that.
with weights too.
Yeah, they were going to go with 55 pounds, and we speculated that might help them with their stability. Now,
there we go. So remember, the rules are that they have to clear the unloaded test flight and then the half-loaded test flight. So from replays and knowing from the last couple of days, they crashed first on their unloaded. Then they must have successfully done an unloaded test flight. They flew, they took off, they landed. And then now they still have to go through the procedures. It doesn't matter how late we are in the competition. They have to prove at half of the weight and also half of the danger. That's what we did there. So we said, okay, we're going to do a stepping stone approach here, just like anything else in safety. At half of the weight, half of the danger, you need to prove that you can fly before we start letting you zip up and down the line, with your full weight. So that is when you see a 55 plus that 2.3 pounds of the payload or the tracker, that's what that is. And unfortunately, it looks like they were not able to do that, but that's all right.
Happy Hellfire out of Pensacola, Florida. Engineering out of that Pensacola town in Florida. Small team building the next generation of heavy lift autonomous drones. And it's still happy, joy for MTech as they have brought theirs back in. And it's still, you can never have enough high fives, as they have moved into second place with still 2 more full days of competition to go. They got to feel pretty good about it. Meanwhile, Happy Hellfire retrieving what they have out there as we are coming up on T-minus 15 minutes in this second flight window of day 5 of the DARPA Lift Challenge.
yeah, we've seen them really struggle to get into forward flight. They have to get off vertically, and then they have to transition to forward flight, but if they don't have the stability or the authority to be stable in vertical hover, then they just can't get over into forward flight, and they certainly wouldn't get back into hover.
That's 100%. That's the challenge. That is their exact challenge with this design. Every team, every design has a different type of challenge, which also makes it fun to get into those physics and aerodynamics of what it is. And then it's back to control theory. It's about power ratios and how much you have left over for, control versus power or lift. And in this case, it's a tough problem. It really is. And that's why people don't do it. But they are like, no, I'm going to figure this out.
Well, you say, I have something I want to accomplish, and the first thing I'm going to do is I'm going to think about all the things that prevent me from accomplishing it, and then I'm going to think of all the existing solutions that allow me to achieve it. But when the thing you're asking someone to do is outside of that, you basically pick your poison. What problem do you want to solve? Because if you showed up here and you just did it on the first day with no stress, then it would that would mean the 4-to-1 ratio wasn't right.
So, and when I said nobody does it yet.
Right.
And that's the cool thing about this. Everybody has said no, that can't be done. These guys are like, I'm going to try. So for this one in the parachutes, I thought about this the other day. What is the applicability? Why would you want to do this? So that, like a hang glider, is very lightweight, very cheap to be able to build, but you have to have a big open space. And just like you see with hang gliders and paragliders, they need a hill, they need the wind to be in the right direction. And so it limits your usability. In this case, think about it like I'm in the middle of the woods.
Right.
And now I've got this very lightweight thing that can lift 220 pounds. That's about a human. I can go up through the canopy and then start going into forward flight with a very lightweight, very cheap capability here, or platform. And the same with the parachutes. That's the concept. You can think about it in canyons, urban canyons, or natural canyons. Anywhere where you need to go up before you start going forward, that's where these kind of capabilities come in.
Interesting. So that is Happy Hellfire as we come up on the final 10 minutes of this flight window here on day number 5. Looks like we've got another team out there, might be getting ready to spin up.
This is the Hovering Owls.
This is the Hovering Owls.
Great name.
Kids from Florida Atlantic University.
I wonder if you know anything about, because I noticed that this one looks like an airfoil shape for the main body and then quad motors, but it doesn't seem like it would have forward thrust when the airfoil is oriented flat.
Correct.
Do you know anything about how this is designed?
Yeah, so what they'll do is a normal quadcopter, you'll see maybe a 10-degree tilt forward when it's flying forward, right? That's about all you need to get up to the speeds. So what they do, unlike a normal airplane, is they angle the airfoil so that at about 10 degrees, it's the lift factor that you want. What that does is it reduces the amount of power that are in those motors and from the battery, therefore allowing you to use less.
So the motors articulate separately from the
No. This one, so as it's flying as a quadcopter, think of it as a quadcopter first, and when you saw those flying, when they were accelerating, they tilted forward about 10 degrees. So now that'll do the same thing. It'll tilt forward about 10 degrees, and then that airfoil will start pulling the load, lifting the weight. So this does, remember we talked about thermodynamics and everything, right? So what this allows this team to do is actually slow down the amperage, right? Reduce the amperage going to those motors while the wind is going over and cooling them. So now it is able to amp that back up or increase their throughput on the hover part, which is the most power-hungry part of the course.
They're in state of hover right now.
Notice they had a little bit of oscillation on the yaw axis. They seem to have settled it down. Whenever I'm looking at that oscillation, I'm saying, is it getting smaller? Is it staying the same? Or God forbid, is it getting bigger?
Yep. So these guys have had some controllability issues. They've been working through them. Last couple of days, they've been going up. They've been figuring out, hey, this is too wobbly, and then they've been coming back down.
Yeah, we definitely see that wobble. And that wobble is, if it's wobbling like that in a nice hover, when you start trying to do those turns, it's probably not going to get better.
Can you get this data of just going up? It looks like they're, 30, 40 feet as opposed to going up 120 feet, or is it going to be the same?
It's going to be the same. Okay. It comes down to, everything that goes up must come down.
Yes.
So if they have a problem, there's two ways of skinning this cat. One is I stay low enough so that if something happens, I don't fall that far.
Right.
And so you're kind of saving it. The other theory is I go high enough so that I might be able to save it on the way down.
Okay.
So wherever they want to, whatever their tactics are and their plan, that's what they're going to run, and they're going to go for one of those two scenarios.
So Hovering Owls out of Boca Raton, Florida, continue in a hovering situation right now as they living up to their names.
Owls. There you go.
And there you see the museum in the distance. Too heavy of cloud cover right now, and the breeze looks like it's dropped just a little bit, so that shouldn't be an issue as we come up on the unofficially final 10 minutes of this flight window, the second flight window of day 5.
We talked earlier about, we explicitly didn't talk earlier about that PID controller, the little algorithm in the computer that stabilizes the drone. But as we look at these oscillations, you think about you're trying to make it stable, you're trying to make it stick, but if you pull it too hard, it'll kind of wobble or shake or we call it a ringing oscillation. So we could be seeing them doing in-flight tuning of that PID controller to try to get those numbers just right, that it's stable without inducing oscillation.
Oh, there you go. They're doing some turns. So they're definitely working on their flight controller there. They did a couple of 360s just to see how that would handle before they kept on going. And now, as you see, they've got weight on here. So the last couple of times that they went up, they didn't have weight. They were just trying to fly empty. Now they're probably working through their flight controller and tuning it. So a little bit more about that PID controller for people to understand. So there's no eyes on this. If you're going around a merry-go-round, you have your eyes, you always know where your mom is, right? Because you can see her. These don't have that. They have inertial navigation systems. They have sensors inside of them that when you move left, it bumps the side and it says, okay, you just moved left or right. The problem with that, especially with these new builds, is that if you don't secure that, the vibrations of the rotors, the propellers, or even just your unintended movements will start bumping that around. And so the flight controller will now start sensing that it's going left, right, up, or down erroneously, simply because you didn't fasten it down.
Okay.
There can be interference as well. So if you have your radio too close to some of your sensors, the RF, the radio frequencies that are coming off of that can electronically interfere with those systems as well. You can even have RF interference from power cables. So they have the battery in the middle, and then their wires are going out to those motors. If you put sensors too close to that, the RF energy that a power cable just gives off can mess with those sensors and totally screw with you. And the hard part about this is figuring out which one of those multiple problems it could be. Right?
Yeah. Yeah, you get a situation where the aircraft is, maybe it's wobbling, or maybe it's making unintended, it's just turning left or right in ways you don't intend. And there's a multitude of things that could cause it. And, you know, when I try to solve those problems on a drone that I've built, I'm usually building a design that has been built tens of thousands of times in one form or another by people around the world for years and years and years. So when I have that problem, I say, well, it's probably one of three things that I did wrong, and I'm going to go find which one it is. But in this case, a lot of these designs, it's either a completely new design, or it's so far outside the normal design constraints that it really could be anything.
And that goes back to that engine conversation about going 200, 300%. The manufacturer doesn't tell you. They're like, hey, this is how it's supposed to be used. If you're going to use that in another way, there's not a lot of data and science behind it. You have to go back to your basics. And a lot of these teams realize that they have to have a number of disciplines to be able to do that. We've talked about thermodynamics. We've talked about engine. All right. So there was a short somewhere in their battery. So as they were unplugging that, it definitely had a little spark, a little fire. Hopefully those guys are okay. We'll see them come back.
That was a rapid departure from the landing area.
I mean, you know, those batteries that they're working with are pretty massive and can make a pretty big spark. I've had that happen to me, and you jump because, of course, anytime there's potential for fire, you want to get some space. But
well, out of the abundance of caution, they're going to have everyone step back.
A lot of times it's not a big deal.
Right.
Let's see how big of a spark. Oh, no, I saw fire. That was not just a spark, that was fire.
A little bit. So the safety crew there did move everybody back off. They're going to let that battery just sit for a minute, ensuring that it doesn't have anything else. We don't see those guys holding on to their hands or any of the ambulance, so we can assume from this vantage point that everybody is okay. They got a little bit of a heart attack, maybe a little bit of a scare there, but yep, looks like they're okay. They're pouring some water on their hands, but we'll come back to those guys and see how they're doing a little bit later.
So hovering owls, look at this, right back out there. He's not scared.
You're going to assess the situation, going to potentially, if you have a battery that potentially is going to light off, if it's safe to do so, you usually want to remove it from the aircraft so you don't lose the aircraft.
Now, just so people don't get concerned, those waves that look like smoke, that was coming off of the runway. That's the heat waves coming off the runway. From this angle, it doesn't look like it's smoking. There you go. You see the heat waves from the runway. But out of an abundance of caution there, we had one of our safety observers, the lane coordinators, walk up with them. They're going to come back and make sure, give it some space.
Let it cool down for a bit.
Yeah.
Well, and I know that one of your intents was to provide a safe space for people to do this kind of experimentation. You know, if these guys said, well, I'm going to try to do this at home, they did it in their backyard or something, they don't have all the resources that DARPA is providing here.
Including that safety part. And so what we've done is, I mentioned this yesterday, that our operators down there are all aviation experts of some sort, or users. So we have uniformed drone operators down there who have years or a couple of years worth of drone operations, and so you can understand the basics, right? One of the guys was telling me about how many times his lithium ions have popped off on him. And so he gives them that space and he says, no, we're not going to do X, Y, Z. Some of these guys, you know, they're brand new to this sport. They're brand new to building and engineering a drone and don't have that historical knowledge of safety to respect these types of things and give them their space.
Yeah, there certainly is a different culture of safety in manned aviation versus hobby drones.
Yep. And that's because, and it's okay, like over at Flight Fest, when you're flying something that's measured in grams versus pounds, you can afford to do a number of things. Their batteries over there are, you know, an inch long, you know, an inch wide kind of a thing, compared to these where you have stacks of cells. So we're taking people out of their comfort zone by building an aircraft like this. We have to ensure that the safety of this type of aircraft is also there, and that's why we bring in the experts. We have all the policy that has been reviewed by safety boards, and we try and adhere to them at all times possible.
That's a brave young man. He's the one that looked like he got...
looks like he cut the blue wire.
Yeah, he cut the blue wire, and he's back out there, back on the horse.
Sometimes if you have a short circuit, which anytime you have flames like that, it might have been a short circuit, the battery connectors will actually weld themselves to each other, and you physically cannot unplug the battery. And then your only option is to get out there and cut the wire. And here he's removing the battery from the aircraft. And let's see what he does with it. Set her down.
So we are coming unofficially to the end of this flight window, and we'll wait for the official word as we take you to the leaderboard and show you exactly what has taken place. We're 2 flight windows in on day 5, and there's the moment we had as MTech moved up to a 3.41 flight weight ratio.
Payload to weight
ratio, thank you. Just moving ahead of Extreme Aerial Concepts. Then you have H Squared and MacGyver rounding at your top 5. Avadrone's still on top with the payload to weight ratio of 3.84. So that's where we stand. And we've got another flight window open up in T-minus 30 minutes.
That's right. And later on, we'll get into a little bit of analysis of this leaderboard. And I think it's really going to be interesting. And I actually saw this on X last night, where people are starting to compare the different styles. And one of them said, because we have 2 helicopters on the top there, or we did as of last night, one was battery powered and one was gas with the turbine engine. So it was the battle that people are talking about. And that is what is going on in this realm. And it's really interesting to see how far electronics have come to be able to compete with a technology that's been around for decades.
Yeah. Yeah, when we did our interview before the event, I went out on a limb and I said, well, I'll make a prediction just to make it interesting. And I predicted it would be either a VTOL wing or a traditional rotorcraft like a helicopter. And I predicted that it would almost certainly be liquid fuel, that batteries just don't have the energy density. And I see that I was clearly wrong about that last one.
Right.
That there's teams that are very competitive with batteries.
And that's the amazing part. That guy, his dad owns a battery business. And so he was able to create his battery. And that just shows you that, we talked about it before, right? The rising tide lifts all boats. So now that we see this and we see that there is a battery that can do this, everyone else can now start building to that technology.
Right.
All right, well, we are going to go ahead and wrap up this flight window. It is officially closed. That means we are less than 30 minutes away from the next one, which will kick off at 2 o'clock Eastern time here from the National Museum of the United States Air Force at the DARPA Lift Challenge. Donna, thanks again for your time. We appreciate it. You come back and visit us again?
I will. I'll come back at the 4 o'clock window.
We'll lock it in. All right, so we will step aside, take a quick break. Remember to be back with us at the top of the hour, 2 o'clock. A fresh set of teams will be back out on the flight line to see if they can break the 4-to-1 payload to weight ratio and walk away with potentially $2.5 million here at the DARPA Lift Challenge. We'll see you at 2 o'clock Eastern. We welcome you to Dayton, Ohio on a beautiful day here as we get ready to make history in the world of aviation. We do have liftoff, so here we go.
I can't emphasize enough how friendly everyone is here at this competition.
Initially, we had really crazy ideas, but then we realized, that it's not so easy to do.
Believe it or not, flying better than ever.
Oh, he's going to put it right in the center. Now you're just showing off. Oh! You got
gotta stop giggling.
What just happened out there?
We're testing the limits, so we found it.
Inflatable structures can become a drone that you can carry in a backpack that can carry you.
Seems like we had a little bit of an electrical issue on takeoff.
We'll rebuild that, and then we will try it again.
Avadrone put it up there at 3.84 on the ratio.
Teamwork makes the dream work, and we're doing well here.
It's been an awesome couple of days, and we can't wait to keep on flying here.
Used to be a very unique subset, highly trained group of people at select large companies that designed and built airplanes. Now it is open to the masses. And that is where the excitement comes in. That's where the power of outside of the box thinking has the ability to really change what we know about aviation.
It gives university students and young engineers the rare opportunity to get their hands dirty, solving a very real national security problem today, rather than waiting a decade into their careers to make an impact.
These people, they're literally out in the field right now, turning wrenches, making tweaks to their aircraft, and proving that it takes a diversity of ideas to make that breakthrough, to find that golden nugget that will take us, humanity, to the next level of innovation, the next level of capability.
If we want drones to deliver serious supplies like food, medical kits, or even repair parts, we need to break away from traditional designs and investigate what will push us to a new paradigm of heavy lift.
This breakthrough matters to everyone because it will enable faster and more efficient military logistics, transform commercial and supply chains, and allow for quicker disaster relief to hard-to-reach locations.
We've only got 4 of us here, so we've all got to do a few jobs. We are Defentex, an Australian defence research company. We've headed over to the US to compete in this challenge. So right now you're looking at our loaded check flight. So we've got 55 pounds on there. Our drone weighed in at 15 pounds. So we really went for a lightweight concept with this drone. So currently you're seeing approximately a 3.5 to 1 ratio on the flight right now. We had to rebuild this drone yesterday and last night, as we unfortunately had a couple crashes, but we had enough parts to thankfully build another one. And after a few changes, we're really hoping to get a competition run of 110 pounds in today, but we'll see how it goes. So we've been working on this drone pretty much since the challenge was announced. And yeah, we've been working on it in addition to other projects at work since the competition was pretty much announced, and we got the go-ahead to have the funding and the resources to put a drone together for it. We went for the concept of we're aiming to do the minimum payload, and we attempted to minimize our drone mass. It's been one of the most enjoyable parts of the competition so far, is meeting all the incredible engineers and concepts that they brought to this competition. So that's 55 pounds on there. It's our loaded check flight. But in addition to the regular check flight of just up and back, we're also doing some tuning of the controller at the moment.
So we don't see the green mark at the top right saying that they're going for a run, but there you go.
And a big set down.
Big, hard set down. Those motors were pulling hard to lift. Perhaps it was overweight. It was maybe one of the motors got hot.
The first run was good. We were just checking it. It wasn't an official run, but we were trying to work our way up to the full 110 pounds, because our strategy is a bit weird where we have to lift 110 pounds to score. Like, our ratio is already very high, but yeah, everything's a bit hotter than expected, and also we haven't had much time to test stuff, so we're kind of learning on the fly. The second flight, I don't know, lost power. I'm not sure why. Yeah, it still had control and stuff, but I pretty much went to full throttle and it was just sinking. So we'll have to investigate what it was and build another one.
Imagine carrying 4 times your own body weight. Crazy, right? We want a drone doing exactly that. That's the challenge we here at DARPA are throwing at inventors across America. And if they succeed, we could see a whole new generation of propulsion systems. Today's drones are limited by how much thrust they can generate for their weight. Some drones can carry a lot of weight, but they are very heavy and cumbersome themselves. But what if the teams competing in the DARPA Lift Challenge create ultra-efficient motors, revolutionary propellers, or entirely new and previously unimaginable ways to generate thrust? Suddenly, a compact drone could carry equipment that today requires something much larger and way heavier. More efficient propulsion could influence cargo, emergency response, and future air transportation systems. More lift, less weight, better performance. Sometimes when engineers chase an impossible-sounding challenge, they end up reinventing the future.
I figured for something like this, actually, like a very small team was actually the best thing because you can move very fast. So I actually built the first drone before I was even accepted as a team in this. I like just assumed that, you know, if I tried my best, I'd probably be accepted. And so I built the first one, you know, like less than a month after the challenge was announced. And then I've been test flying since then. So this is actually the 4th drone. Basically that I've built. So, but in terms of, you know, I went for very simple. Like I've built a lot of drones. I know the stuff that works and the stuff that doesn't work typically, and so I wanted to keep it, you know, as simple as possible and like realistic. And so I did a lot of simulation work on what is, you know, the least amount of structure I can use to still lift reasonable. This thing is actually like rated for up to like 250 pounds. So hopefully I don't eat my words out there, you know, with less than that, but it is rated for a decent amount in this iteration of the design. And there's a lot of small things with the design to optimize wiring and how the motors communicate. We were able to get away with not having certain components because of how I did things. But the main innovation with this is the battery. It's a custom battery that I made. That allowed me to maximize my energy density for, you know, the weight that I had left over in the budget, basically. I'm definitely willing to crash it, so, you know, we'll see. Oh, I just bought like a $3,000, you know, pretty junky Sprinter van, like an 05 Sprinter that's pretty much fallen apart, and that's what I use to transport everything for flight testing, and you know, did the bare minimum to fix it up to drive, and that's what I got here. Drove all the way out here, had to go 50 miles an hour the whole time because it basically can't do more than that. So yeah, so that's what I'm working out of, you know, self-funding. I spent all the money on the drone, I didn't spend it on the transportation, you know.
Obviously, the hard deck is not in play. Seems like they're bringing it down.
Yeah,
Ooh, a little wobble there.
Pretty quick.
Oh, they lost the weight, and it jumped back up in the air as that weight freed itself. The pilot maintained control expertly.
I don't know.
No, that wasn't on purpose. No, sorry, that was not on purpose.
But you never know, like when you start going, how the position control stuff is going to go. So, yeah, lost too much altitude in one of the, you know, far runs, and it kind of just barely breached over there. So, had to bring it back, and then wanted to do some more tuning, and you guys saw how that went. You know, it was coming down a little too fast, and even though, you know, I was 100% throttle, I still couldn't keep it from, you know, hitting the ground. But it didn't hit the ground that hard because, you know, all it did is really break the straps, and then as soon as the weight is gone, that, you know, that thing has a lot of power, so just shot straight up. So, but we're all good. Everyone's safe. Everyone's all right. I think I'm gonna give it another try. I have a second drone actually, and I have another battery. We'll try to crash it again or do it successfully.
Being here at this museum is amazing. It is filled with design innovation. from brilliant minds who have thought outside of the box. DARPA has been a part of many of these designs that are on the floor, on the ceiling. It's really exciting to know that the top 3 performers out of this challenge are going to be here. They're going to be displayed. They're a breakthrough. We are making history at this challenge. For me, this is just a stamp in time, this one challenge. What's exciting for me is to think in 20 years, how many more designs will be around these hangars? How many will be here that were inspired by this challenge, by the things that you brought, that the teams brought to this challenge? What does that future look like? For me, that is more exciting than this one point in time, this one challenge, and the week of flying that we are doing. The future is being created, and it's going to be celebrated in these hangars for decades to come.
Here at the DARPA Lift Challenge, safety is paramount, and that is why we have partnered with the Federal Aviation Administration. From the outset, we designed this competition to uphold the highest standards of aviation safety while pushing the boundaries of innovation. Every operation is conducted within a structured flight environment that enforces clear boundaries, layered safety zones, and strict response protocols. All remote pilots participating in the challenge are certified under Part 107, meaning they have demonstrated a comprehensive understanding of airspace rules, emergency procedures, and safe unmanned flight operations. But beyond certification, these pilots bring something even more critical. They and their teams have intimate, hands-on knowledge of the aircraft they are flying. They have designed, built, tested, and refined these systems, giving them a deep understanding of performance limits, failure modes, and recovery actions. This combination of regulatory compliance and engineering ownership ensures that every flight is conducted with discipline, accountability, and precision. At DARPA, advancing technology never comes at the expense of safety. It is the foundation that enables innovation to move forward responsibly and ultimately transition into real-world use.
We crashed and burned. We had nothing left to lose. We were like at the absolute bottom. We were almost in tears.
Believe it or not, we're back, and we're flying better than ever. We had this extremely beautiful craft that is highly engineered. It's like a race car. Everything component's been dialed into the max. We had custom everything, and we had a component fail on one of those power boards that immediately cut 2 of the motors, and that's when you saw the aircraft do that flop. Dropped 125 feet from the ground and landed on its top. The root cause of the power failure, we suspect it might have been water. Just the morning dew. You get water in the wrong spot, and that's it.
The theory is that this capacitor sustained damage, failed, which then created the electrical conditions to cause a larger catastrophic failure here.
We have a bucket of all the components we've ripped off. You can see how the carbon fiber is all just destroyed and it crackled and sprinkled. But thankfully, like saving grace, the pods grenaded, but the ampresses were inside of these pods, buried inside, and because they grenaded and took all the force, yes, it was bad that they grenaded, but the batteries are fine, it didn't explode, we still have an aircraft. We came back here with our tails between our legs being like, oh man, this looks so bad, because it had fallen, crashed, caught on fire, and then Crichton, our CEO, comes to me and says, can we fix this? And I was like, okay. As one of those things, like maybe we could bolt some 2x4s on. You're thinking, you're grasping at anything, and then it turned out that was the best thing ever.
This is our homage to the Wright brothers. The airplane was made out of spruce and balsa. Yeah. Ours are 2x4s from Home Depot.
Transformed from an F-35 next generation to like an A-10 tanker, like really just rock solid. So it's not as sophisticated, Man, but it flies beautifully. I mean, Greg here can attest, like, it is a dream to watch.
Like once it goes into that final flight configuration of spin, you know, which is what it's designed to do, it just locks in and it becomes very stable. And that's how it's meant to fly. You know?
It was designed to spin, and it does so beautifully. It was spinning fast enough to generate lift that you had to back off on the throttle.
We were just going up like a rocket, had to drop the throttle, and that just turns it in from a inefficient craft taking off like a quadcopter to a really efficient high lift aircraft.
It's forced us to simplify so many parts of our craft that the process of doing that and thinking that through has resulted in a mode of flight and a design that we think is, possibly in some ways better than what we had.
We spent so much time with the math, with the theories, with the formulas, trying to dial in that 4-to-1 at the 30 minutes, the 4 nautical miles. And in doing that, everything gets more complicated and more complicated and more complicated because we're chasing those decimal points. All it takes is one small thing to go wrong and the whole thing just falls apart. So simple, 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 robust, robust, robust.
Plan is now, by Sunday, we're dialing things in because, there's a lot of things we've still got to change and improve. We've got a lot, we can turn those 2x4s into Swiss cheese and reduce our weight. There's a lot we can do. And the plan is by Sunday we'll be at pretty much as good as we can get with this craft. The camaraderie has been amazing. We've probably done 2 years of R&D in 8 months. It's just been insane. Coming together day after day, how do we do this? And, we've got that respectful disagreement, which is what you need for a team operating at this level. People are contributing ideas, critiquing ideas, providing feedback, and at the end of the day, we're like, this is collectively the best way forward, and we're all on board every time that happens.
It's really compelling, just seeing everybody rolling with their own little punches, and you try and overcome it and you find the workarounds and you make it work, and you sort of see how that plays out for everybody in their own little story.
Through this competition, I'm hoping to find new powertrains, new aerodynamic designs, and new combinations of things that were not thought of before. So when the next aircraft designer gets up there, instead of just saying, I'm gonna do what has been done for the last couple of decades and make it slightly better, they now say, well, wait, all of these other things are possible. With these ingredients, what can I do that has never been done before? And what we're seeing out here over the next couple of days is pure innovation, unbridled, and it's just amazing to be a part of.
Scientific engineering failure is a great thing. It's the way we grow. As scientists, without making mistakes, we don't learn to understand what the fault was. So the more you make the right mistakes early and learn from them, the better you are in the long run. Success for me is inspiring the community, not just the military community, but the public on trying to come out and do something that they're willing to try that's never been done before.
What I'm looking forward to once the Lift Challenge is completed is reflecting back maybe next week, a month from now, maybe a couple years from now, and knowing that I had a small part and role in making history.
What I can't wait for is the product of that. What's going to happen in a year, 2 years, 5 years, 10 years? I can't wait to see what comes out, what industries are made because we make this breakthrough, what new capabilities and companies and organizations sprout from this challenge right here.
at the end of the day, we're all high school students. I'm 16, I'm a rising junior. These guys are 17, they're rising seniors. And yeah, my friend over here, Otis, when this competition ends, he's gonna have to fly out because he's got his first day of school going on. I've got my ACT and APs that I'm taking this year. And there's a lot between managing this school. We also had tight budget considerations. We had a $5,000 budget, so there was a lot that went on.
I think the hardest part of it that I was part of was the laying down carbon fiber over the wing sections. So you can see we have a lot of these. What these two did was they took a bunch of old 3D printers, they took them apart and made a CNC foam cutter. They cut out a bunch of foam sections for these airfoils, and then they laid carbon fiber down and vacuum bagged it. After that, I mean, these are hollow now, right? So they melted out, they dissolved out the foam from inside of them and saved a bunch of weight. That was a huge, huge process. A lot of all-nighters that they pulled, and I helped out with a lot of that. So yeah, that's one part of the process.
So why is now the right time to tackle this? Because we are witnessing a unique convergence of technologies. Recent breakthroughs in advanced materials, open source flight controllers, and rapid computational modeling have fundamentally lowered the barriers to entry. The cutting-edge tools that once required massive traditional research facilities are now accessible to independent innovators. The technology has caught up to the ambition, making this the perfect moment to solve this challenge.
The actual reality of what you can do with a 3D printer is astounding. You can make structures that were impossible to create 10, 20 years ago. Or you can also make structures that were only able to be created at very, very large companies with a lot of money.
Now, anyone can pay for inexpensive software to use the computer to design something that just comes off of their imagination and run some simple analysis codes. It's enough to get an idea going. Pretty quickly, you could do fluid analysis, you could do structural analysis, you could do stability and control without having an incredible depth of education.
Another aspects are power plants. So whether you're going electric with battery and motors, or you're going internal combustion engine, powertrain dynamics has really exploded in the last 10 years as well. So not only the designs, the different sizes, variations, and all of that sort of stuff, but the availability of it. You can jump online, buy something, and have it at your doorstep in a week or 2 weeks. That wasn't able to be done just 10, 20 years ago. So when you have all of these factors combining, you have this ability to innovate and to change the way that we have designed, built, and flown aircraft compared to the last 50 years of aviation.
History shows us something fascinating. A technology doesn't necessarily change the world when it is invented. It changes the world when it becomes affordable enough for widespread adoption. Take the automobile. For its first 20 years, the car was a toy for the rich. It didn't change how the world operated. But when Henry Ford brought the cost of production down, it completely restructured human civilization. We also saw it with computers. They were around for decades, but until the personal computer was created, they didn't have a significant effect on how we lived our lives. And today we're seeing it in space. Space used to be a domain exclusively for superpowers and the exquisitely funded. But by transitioning to reusable rockets, the cost plummeted, and suddenly a massive commercial space economy is emerging that we previously thought was impossible. Today we're standing at the edge of the next great technological inflection point, heavy vertical flight that is economical for widespread adoption. Right now, if a company needs to move cargo, they run a cost-benefit analysis, they look at trucks, trains, and ships. Helicopters and drones almost never make the cut. Why? Because the cost per pound per mile transported is just But because they don't scale well, they're limited to tiny payloads. Breaking this weight barrier will revolutionize military missions, allowing us to supply our warfighters anywhere on Earth at a fraction of the cost. In 2004, the DARPA Grand Challenge sparked the self-driving car revolution. The communities that formed in the desert that day went on to build an entirely new global industry. This is exactly what we are doing with the DARPA Lift Challenge. We are building the community, proving the hardware, and giving America the jumpstart it needs to dominate the multi-billion-dollar aerial economy of the future. This isn't just about building a better drone. It's about redefining how human civilization operates.
Oh, he's going to put it right in the center. Now he's just showing off.
Oh, yeah. Well, you got to do it.
Congratulations, as they are out in front right now, the leaders in the clubhouse. I love the attitude, JB. They're going right back to headquarters, and they are coming back all firing.